photo, whatever it is, at some point in time, your creative flow will be disrupted because you need to wait for too long.
But there's a really nice parallel here with when smartphones started grabbing a hold, where it's both a matter of you getting the benefits of what smartphones offers compared to brick phones, but also that all of your customers are there. So if you're ever going to interface a customer with an app or a website or something like that, like who here doesn't have a website that works on a mobile screen? It doesn't work anymore. You have to have one. And it's the same thing with AI. You both need to know how to use it, but also because that's where your customers are going to go. And we tested it by asking a question to this CEO woman that I met. You know, somebody wants to find a new office venue. They're going to ask a chatbot. And the chatbot will answer and send some links. And she's like, why isn't my company listed there among the links that the chatbot supports? You know, Google used to be the way to do it. And now my customers are trying to find things this way. Maybe I need to be savvy on this stuff.
So we're talking about search, SOE going into AIOE or something like this. I saw this.
You just need to be aware of what's going on.
I mean, I think the future will be similar to smartphones, that everyone expects that a smartphone should work simply. And I remember I gave some kind of math advice to a friend of the family, and she was trying to struggle a bit to solve the math equation, and I simply took a picture with the phone, sent it to ChatGPT, and asked it to explain the problem and give a solution, and it did. And I said, isn't this amazing? The AI can understand the text and solve the math. For me, it's amazing. And she was, what do you mean? That's obvious. There's nothing strange with that. AI is supposed to do that, right? I use Snapchat every day. That's nothing strange. For them, it's obvious that any kind of product that they use should have intelligence in it. And it should be like ChatGPT level. Otherwise, they're very surprised.
But for me, it was interesting to be there, Chairman Data Innovation Summit. We go to all these conferences and we can all nerd out, right? And here you meet a normal crowd.
Normal people,
not in our echo chamber, so to speak.
Yeah.
And the communications or knowledge gap is so big. So the stuff we're talking about here, and we are throwing around llama, anthropic, blah, 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 they don't even know it exists.
Yeah.
That really shocked me a little bit. But at the same time, why would they? Why would they care? No one cares, I guess.
Yeah, but I was on a podcast a couple of weeks ago with completely different branch of people and knowledge, but they're into recruiting and executive search stuff. So of course they're more and more meeting these kind of questions. What do we need? What does it actually mean when we say that we want somebody with this kind of experience or knowledge or role or whatever it is? And I thought they started off really good because they asked me, what is AI? And I gave this example.
What did you answer?
That's a good one.
I realize I'm in the fighting pit here, but I tried to give as easy as possible answers when it comes to how to see what it actually can give us. And I gave them the example that if we see machines as something that can, help us overcome our physical boundaries. Us around the table cannot lift like 3 tons of something, but so we built a robot or something that can do that for us. So we build something that can actually make sure that we're better physically. So they do stuff for us, and we're so used to the fact that we can get physical help. So we don't see that as something that sort of interferes with our core of being a person or human. But nowadays, when it comes to AI, and that was the other part then, that this is something that can help us or, help us overcome our sort of what we don't do as good when it comes to our cognitive abilities. And that's where AI comes in. And just the fact that we're not so used to the fact of thinking that something else,
can be smarter,
can help us think. It can sort of, make us better cognitively or intelligently, or how you want to say it. And it makes it fairly easier to understand. And it's also maybe easier to then look at the thing that, why do we see it as, potentially a threat? Why do we think that this thing that thinks and maybe thinks better than we do? Why is that something that we feel is, we're into human turf here? So I think
scary
that's
for a lot of people, right?
Yeah, it is.
Yeah.
But I've been getting feedback, which is nice. That was as an easy way to see it, especially when you're not used to having, the very depth of conversation which you are accustomed to, and that our little echo chamber.
But it's also clear about the echo chamber that in reality, sometimes we work in a large enterprise and we are trying to help them, right? And we might be talking to the tech people, and we might have a fairly good conversation, and we understand what we're doing. But in reality, that same conversation where the marketing director doesn't know what llama is will happen everywhere, from the large enterprises to the medium-sized companies. So to excel in this communication, and I thought you did a pretty good job. I thought who was the woman from HP you shared the stage with? I think she was
the chief product.
Chief product.
She was a chief product officer.
Chief product officer for this new line of products, and I think she did a fairly good job in connecting with it, and then I like the idea that you were trying to also do the demo. For them, what I think is going to be a leap is that in a couple of years they will build their own agents. They haven't really realized that. So now they're feeling okay. We're going to use ChatGPT. We're going to use these products, and they're like, actually, you might likely be able to string together an agentic workflow yourself.
Yeah.
And then you even more need this type of machine. And this one is completely out of. They are not there. But it's so obvious it's going there, I think.
I mean, it's more than obvious. I saw a post on LinkedIn of somebody, or perhaps it was Reddit, and then reposted on LinkedIn, as is usually the case. Somebody was complaining and saying, my Python project that has 30 files in it isn't working well in Cursor, and the AI isn't able to track all of the stuff across the files. That's pretty damn amazing. That you can have a project with 30 files in it, and the AI is still sort of keeping up and then sort of breaks down. Well, we're a few years into the sort of LLMs that are able to do this kind of stuff. It's only reasonable to expect that it's going to grow in the next couple of years. What do you think? I mean, no people don't work with projects that have hundreds of files in them. These are really, really senior developers that do that kind of stuff. Most people don't do that. And it's cool that AI is almost there today.
Yeah, and then it comes this whole, I was thinking, and I was talking a little bit with Albert at HP, how this whole journey has gone. Everything is on-prem. And then the pendulum flips over, or everything is in cloud. And, the last couple of years it's been like, everything is about the cloud. And people even stop forgetting about the physical edge of what they're working on in their workflow. And I think my prediction is that as we are now, as our phone are getting more and more powerful, the machines are now getting adapted to have AI flows in it. And maybe we're not even going to call it an AI PC in 5 years' time, because it's going to be so ubiquitous. I don't know, but it's quite clear that we're not going to send every single thing we do to the cloud. We're going to do something local and then send some stuff. I think that's a clear trend here. I don't know.
It's a shame that there's a lot of AI fatigue out there.
Yeah.
Everybody's hearing about AI and they're like, I hear about it, I don't get it, and it seems like it's a bunch of hype. And when I tested the model myself, it was no good.
2 years ago.
I'm not sure exactly what to do about that, but sometimes it's nice to just stay in the bubble and enjoy it.
Yep. Tough discussions speaking about and handling and managing, I think, the AI hype that, some people are, of course, there is a true value, and it's amazing the progress that AI have had in recent years and over the last 50 years as well. But still people are so ignorant about what it can do and cannot do, and believes it can do so many more things that it actually can. And then we have people that are
and we are
and
truly,
that is really bad that we have this kind of people that are not really managing that properly. Annoying.
But I think we also need to have respect that we are actually in our own echo chamber. We really need to have respect that we are outnumbered here. The gap is not only a geopolitical gap, AI divide. It's a microcosmos divide between people who are working with it and people who haven't really touched it, and we need to respect that. And start there.
Definitely. I mean, that's a huge. We've been talking before, I think, about the value about science communicators. Yeah. When you're able to make something that is either perceived as being very complex, or that is complex in its own, and to be able to bring that to people so they don't feel like it's super hard or not for me. I will never get that. It's I could never understand
the great
those
communicators
things.
that can actually speak about complicated things properly, like Richard Feynman, in the 1940s, speaking about quantum mechanics, in a way that was so engaging. And it's very few people that can actually do that.
But I remember from this pod, you said something, maybe it was you or someone said it to you. So how do you define who's the best data scientist in the team?
Communication.
And then basically the bottom line is, well, engineering-wise, what we can argue back and forth, but the one that has biggest impact is the data scientist that can communicate with the rest. And that is communication again, right?
And I mean,
As a
maybe
key
that
skill.
then applies to the whole field. And if the three of you are especially then representatives for this field, of course, there's a responsibility to make sure that you don't make it more difficult or harder to get close to, and that you don't, have a point of alienating people from,
But so are you. And I would love to welcome you here as well.
Thank you.
Louise Vanerell. And you are actually an expert in this, I would say.
Thank you.
How to work with leadership and navigate the future of AI, and just how to keep up with the amazing progress that we're seeing. And you have a company called
Recursive Future,
right?
Yeah,
what do you do there?
Well, Recursive Future works with precisely these things, which is how do we make sure that the people working with these technologies and the people who are working closely to them actually have the knowledge and the capacity and the skills to be able to work with these kind of tasks. And I love to sort of bring it from not only talking about, what do people have to know, but rather what do we want them to be able to do. And as soon as we have that thing more figured out, then it's a lot easier to actually set up to make sure that people get that kind of knowledge. So that's what we worked with, all the human factors regarding the technology that we are seeing the revolution of, so to say.
And dearly needed, given what we just spoke about as well before. So kudos for that, I think.
Thank you.
I would love to welcome also an old friend here, Robert Luciani. He is annoyingly a very multi-talented person that is both an expert programmer, Julia lover, of course an AI wizard.
This is the year of Julia.
This year is for real.
It's
2025.
It's like quantum computing. It's always the
it's
next.
just around the corner.
Mikael Klingvall always says that I'm working with, I can't believe Python beat Julia.
Yeah.
Julia is so much better. What if the whole world had went my way?
Let's pin that. We can get back to it. I have a feeling it's going to show up again.
But also, of course, an AI wizard. I think you call yourself actually one of the most knowledgeable people in AI that I know. So I'm very happy to have you here as well.
Awesome as always.
And it's going to be a bit of a special episode, I think, today. We have even less prepared than usual, which is hard because we don't prepare that much.
I think we prepare. We have our themes, we have our questions, and the guests have them beforehand. Now we have topics.
Yeah. No, but we're basically planning to speak a bit about the news and have a proper after work, sitting a couple of friends and speaking about the favorite topic that we have.
Yeah, and in my way, the news wheel of new things coming out is spinning so hard. So we usually have a news section that we do like 10, 15 minutes. And then we did it last year with Jesper, like when we used to take a full episode and dissecting some of these news. And I think we are right at that cusp again then last time there was the star, Q star, and then all of a sudden we have O1 coming out. And now
After, it was so annoying.
The day after you had it, you were predicting the day after it was released. And here now we have, everything that has come out now with Grok, with DeepSeek, deep research, and we really have seen now the new breed of reasoning models, and we all had maybe some chance to play with it and all that. So it's a time to reflect on where we are right now again.
And more stuff coming up very shortly. Sam Altman is announcing GPT 4.5 around the corner. And
so we can do the Q star. We can go back to the...
Probably tomorrow they will announce 4.5.
If we predict it today, they announce it tomorrow.
Yeah, we make it come out tomorrow. The podcast,
this podcast, if we predict it today, it comes tomorrow, right?
But also before we move into some of these kind of most interesting news and perhaps some research papers and whatnot that we can discuss, I heard also, Robert, that you have a new adventure as well.
Yeah.
What are some new exciting events happening for you?
There's always side gigs going on in the background, but I have settled with one of my customers and taken a job there, and that is the Swedish National Television, SVT. I'm very happy to be working there because everything they have is content, which is great for AI people. It's pictures, it's text, and everything else, and it's a small team, and as you know, small teams can achieve a lot, and we have a very clear vision of wanting to be able to jump ahead really fast, and it's possible. So I'm excited.
I heard you had a cool job title.
Yes, I'm the only person there called AI Wizard, so I'm very happy about that.
It's actually called AI Wizard.
That was actually part of the discussions for getting the position.
I'm not going to get on this job if I can't have AI Wizard on my...
Yep, that's what it was. They're like, all right, we'll make a concession this time.
I love it.
Awesome, it's so cool.
You should wear that with pride.
Yeah.
So can you elaborate a bit more? What are you going to work with? Or
Yeah, for
anything you
sure.
can share?
I mean, they've been pretty advanced for a long time with certain types of technologies, from streaming really high bandwidth, because they have a mission that they have to work on all devices to everybody all the time and be super reliable. So things like translating between languages, archiving things, and other things. They've been doing AI projects here and there, and so they have very many teams that have a little bit of AI skills spread out across the company. And even recently, one guy that just joined my team, he was in another team earlier, is a super expert at Comfy UI. And they've trained LoRa's to do, the things that they wanted to do, but with Swedish landscape, or in the style of their own drawing artists and that kind of stuff. They've trained LoRa's that make sort of not thumbnails, but kind of art that they need for shows and stuff like that. And so now what they need is a platform that enables automation of this kind of stuff and scale out and self-service and a lot of kinds of things like that. And I have a bit of a grand vision myself, which is that you have one chat interface for everything, and you should be able to ask it a question, and it returns custom CSS where you can fill in your parameters, and then it'll generate a picture for you, so you don't have to be an expert in Comfy UI, but the Comfy UI person can set up like a workflow. So we do need to enable agentic type flows of events.
Can you just elaborate? What is Comfy AI?
So Comfy UI is a user interface for mostly image and video models. And it's quite complicated just because sort of the domain of diffusion models and all these things have a lot of parameters. So the UI looks really neat. It looks like you connect cables between all the inputs and outputs of these models, and it can really look convoluted. And you can download some pre-made configurations, but this guy makes his own. And
well, it is for generating images, basically.
It's for generating images and video. So if you have a picture or a video of a landscape and you're like, I want it to look more like northern Sweden, you can run it through a pre-made workflow that he has made that will remake it into northern Sweden style. Stuff like that.
So is this then to be used sort of instead of stock photos and stuff?
Instead of stock photos, also, for example, they have artists that work full-time on drawing things, and they have drawn tens of thousands of pictures from courtroom proceedings.
Oh, yeah, of course.
They don't want to draw more pictures like that. And that style is so uniform that creating a LoRa, which is like a custom little model.
And what is LoRa stands for?
Low rank adaptation, I think.
Low rank adaptation.
That's just a way of sort of nudging a model in a direction that you like. And so this nudges the model to turn every photograph into a drawing in the style of these artists. So instead of having to ask the artist to spend an hour making a drawing that they hate to make, you can just use the LoRa to take a photo and turn it into a drawing like that. Yeah. And so we want all of this kind of stuff to be self-service instead of having to ask our Comfy UI expert to do it by hand every time. So what we need to build is a system where people can help themselves, can manage their own prompts, can manage flows of prompts, and build agents and that kind of stuff.
I love this vision, and it resonates so well with on a much deeper level, that the way we really create autonomy for people using AI, is to build products, is to build ultimately self-services.
I just have to share one anecdote, which was basically on the first day that I was there, I got to meet a lot of people, and I got to meet this prize-winning journalist woman who, she's an older woman now because she's been around for such a long time, won lots of prizes, and is a good journalist, right? And first of all, everybody's very excited about AI at SVT, but this woman in particular was so creative with the way she wanted to use it. And, you can imagine, let's say you have a RAG setup with a database of articles and stuff, and she's writing an article about something, and she needs to know something in order to build an argument in the article she's writing. She can ask way better questions to dig up information than I can, because of how good a journalist she is. And she's like, you know what? I bet this is relevant. I'm going to ask this question. So the way she imagined using the RAG system is way more sophisticated than what I would be able to imagine as an AI expert. And I think that's so cool that you see the domain experts being the ones that show you this is really how we want to use it.
Yeah.
I thought that was pretty neat. So I find that it's always the people straight out of university or the oldest, most experienced people that have the best ideas when it comes to AI stuff.
Yeah, but it's also so clear with the self-service thinking, the co-creation between the domain expert and the tech, the engineer. This is the power. Anyway.
I mean, also, I certainly subscribe to the idea that if we can make it self-service and truly enable non-technical people to make use of AI, we can scale up the value of AI so much more, because we usually have so many more people that are, not super experts into AI. And I actually heard you mention something very interesting in SVT as well, which is something like, and please correct me if I'm wrong, but something about the CMS for prompts or something.
Yeah, this was actually an idea that they had before I even joined. They used the chatbots to draft things and to double check if they hadn't maybe sourced things correctly. And so they had sort of workflow ideas. And so what they had done was a lot of work on prompts before the user asks their question. So it would be a long prompt and say, I want you the language to be like this. If the question is like this, then do that. If, and so on. So like long pre-prompts, I guess.
Like system prompts. Or
pre-prompts. Yeah, exactly. Like system prompts. And they had generated so many of them that now they have a prompt content management system, a prompt CMS.
So cool.
And there's a business owner on the business side that is not a technical person, that is like the AI product manager for the chatbot. And his job is to manage the prompt CMS and talk to the business and say, are you getting the responses that you want? Why is it good? Why is it not good? That person is
so mature.
That person is responsible for if the service is good or not. We have no idea. We can say if it's up or not, or if it's many tokens per second.
He content-wise, qualitative-wise, has a better view on this.
Like you and I have been discussing a couple of times, like it's so important to see where the value comes from, and having somebody in that position take that sort of responsibility, of course, sort of make sure that you get the value from doing this kind of works and having that sort of setup in place.
But this is also interesting now. Like there's a lot of people now. They're putting on Copilot. They're putting on ChatGPT. They're making an enterprise approach to it. And they give you some basic teaching on how to do this, and off company goes. And here, come on, this is going to be Excel hell all over again. So here now I'm so glad to hear someone sort of having a framework idea, a product idea, and then thinking about how can we steer this in a responsible way. Yeah. Super cool.
One thing we probably think about as engineers are like evaluation metrics. How can we check if our deployment is performing as expected? And we try to come up with things ourselves, and there are these pretty clever ways of doing it. One of my favorite is my old colleague Liang Feng. He said you can ask a question from the model and then see if the model can infer the question back from the answer. And if it can do that, then it's a precise answer and not a vague one. That's just one kind of metric that maybe is important, or maybe not. It doesn't matter. And so engineers will try to come up with metrics for whether the models are good or not, but really we don't know. It's only the business people that know whether it's good or not. And so it makes more sense to have a business person managing and sort of being in charge of whether the service is good or not. I really like that.
And this is what AI really enables to more, to a higher extent. You don't need to have a super technical skill to make use of technology in some sense. Right?
Yeah.
Yeah, but there's a profound back depth to this, because we have anticipated that when you look at using AI and AI agent, it will fundamentally rebalance the workforce. And a simple way of saying it, well, you will need people who are managing the AI, simply put. And then, what the fuck does that mean? Here we have a very concrete example that we can't all be journalists. So within the journalist and within deep domain know-how, someone is now taking on the CMS or product owner role for the prompting. So is he an AI engineer? No, but is he way more advanced in AI than the journalist who's the user? So we are now getting a rebalancing of the domain teams versus the tech teams. Yeah. And in the beginning, maybe those guys needs to be fairly techy, but the more we are better in the platform teams to build self-services, it will shift. And this is a major impact, because if you're not thinking about this rebalance, it's going to be troublesome when we think we're going to have exactly the same profile, balance of teams, and not really fixing this.
But tying back to what you said earlier about who's the most valuable AI engineer on the team, the one who can communicate. Because obviously that's where you build the bridge to somebody who is that person, like in this case then the domain owner or the product owner.
This person has become technical, so they weren't technical to begin with, and they've been on every stand-up meeting on every Monday with the tech team. So they are a part of the
if you look at the report from a reporter point of view, he is the AI engineer in their team, clearly. Then if you look at this to like you as a nerdy,
AI
hardcore,
he's the business guy.
He doesn't do assembly coding.
No, so they're very far ahead of many other organizations in that respect. I thought that was pretty cool.
Yeah.
And perhaps they will start to do coding without Julia in the future, because business people actually can code in natural language.
I think so.
How does that make you feel? Let's keep that question a bit and get back to the future of coding, perhaps, and see how we can enable potentially business people to not only use AI products, but actually develop them, which could be
interesting.
Should we start digging into some of the obvious news question that we have to at least speak about, and then perhaps get more into some more interesting ones? But I think we have some obvious news items that we have to basically tackle.
Yeah.
And I guess we have to speak about Grok 3 then, to start with. Anyone that wants to start off and give some thoughts about, what's so special with Grok 3?
I got Grok 3 immediately because I've been using Grok instead of OpenAI since last year. And I can already say that Grok 2 was very good. There's something very weird in the, I would say both the performance, but also sort of the tone. I don't mean tone like it uses words that...
Before we go too deep here, perhaps we just need to give a quick backdrop to what Grok 3 is.
Right. Grok 3 is a model like ChatGPT, but by the company X, formerly known as Twitter. So X has its own machine.
XAI, rather.
XAI, that's right. So a company with the mission of creating AI models, and it is served through the X platform right now. There's going to be phone apps. There's one for iPhone just came out, and one coming out for Android pretty soon.
And it's going to go into space, I've heard as well, through SpaceX.
It's going to go everywhere. Yeah. And everybody's competing to make the best model, obviously. And XAI is a very young company, well funded though. I guess I should say by
strong people behind it.
Yes, Mr. Musk, deep pockets. And but not just deep pockets. The XAI team seems to be a real SWAT team of super experts.
Well, I'd love to speak about the speed angle, so we can focus on that shortly. But I love that you actually have experimented with it yourself and have some concrete experience with it. So what if you just go back to like Grok 2 versus Grok 3? What was the difference in your view?
I just want to mention the thing about tone. I always tell people to test models themselves to get sort of a feel for them. It's something about the way they understand what it is that you mean. If you ask a model to give me a summary of this and that, some models will give you bullet point lists, some will give you succinct answers, others will be very wordy and soft.
Verbose.
It doesn't have to be like politically correct or anything. It can just be the style of the way they like to converse with you. And you have to get a feel for what you prefer. And I just felt that Grok was to the point, and always answered exactly the way I wanted. So I got a preference for it when I switched from OpenAI. Now Grok 3...
And that was over a year ago, right?
Like 6 months ago, something like that. And Grok 2 was very good at that time. It didn't have as many features as OpenAI. Now Grok 3 came out and it has 3 big features: the chat feature, the think for longer feature, and the research feature. And I think we need
Deep brain as well, right?
Maybe. I haven't tested that in that case. I think we need to talk about them all separately. So Grok 3 has been secretly competing on LLMs chatbot arena for a long time. And, as engineers, I think we all have respect for that. Benchmarks are just benchmarks, and they're interesting, and they don't necessarily say more than what they say. But in any case, Chatbot Arena for me is a nice benchmark because at the very least it says what do users prefer to talk to, not how good it is or anything.
I mean, I think it's special also. It's not a normal kind of benchmark, I think, in that sense. So just to explain it a bit, I mean, it's basically where you have a blind test. People don't know which model has outputted what, and they basically say, I prefer this over the other.
So it's a user
user-driven. It's similar. They have ELO scores, like whoever is
like
winning over in chess get a certain ELO score, and they can basically put ELO scores on models then.
But the real distinction is that this is a blind test, ultimately.
Yes.
That is really distinguishing.
You don't know which model you're talking to, and you have to say, I like this one more than this one. And there's one more thing, which is that in the past year, it looks like all models have been plateauing. So even though GPT-4 has been a clear leader, and in ELO is logarithmic, so having a few more points means a lot. But in any case, the models have sort of been converging a little bit in the sense, at the very least, that small models now seem to be able to give answers that people think are pretty okay, despite being very small models. And what happened was Grok started competing and just demolished the others. It's the first model to have an ELO score of 1400. And so it's clearly better than the other models. And I don't think it's because it's better, because I don't think users are using prompts that are testing its math capabilities and other things. I think people just like to chat with it. And it comes back to this thing about tone that I was saying. Does it get the way you want to talk to it? It doesn't patronize you and pretend like you're stupid and sort of over-explain things or under-explain things. And so that's the first cool thing. It's a pretty nice chatbot to chat with.
Does it still have the fun mode kind of thing? Or?
No, I don't know if it has a fun toggle anymore, but haven't really used that. The second feature is the Think for Longer feature, and we got a sneak preview of that with some OpenAI models, but maybe more specifically with DeepSeek that made it more popularized among people at home. But the Think for Longer feature is basically that it's allowed to write messages to itself and then read them and use that as sort of like a scratch pad before giving its final message. So basically we can pretend like
it's... Is this the reasoning part?
Yeah, I mean, models now need to spit out their answers before they've finished thinking. And so what they let it do is use a piece of paper that's hidden, and it thinks on that piece of paper, and then it finally gives you its official final answer. And it's very neat because it's very fast. I mean, this thing is spitting out over 100 tokens per second really fast in the background. And so I asked it a question yesterday where it thought for an absurd... Oh, yeah. I asked it to guesstimate the performance of some computing stuff. And it just started talking to itself for a long time. But wait, actually, I forgot to take this into consideration. So it was thinking for like 2 minutes and having this internal dialogue in its head before outputting the answer. But the final answer that came out was really well structured, well thought through and everything like that. So it is a pretty cool feature. And then the final feature that Grok 3 has, which and these are things we've all seen, but they do really well with Grok 3. The final one is... I think they call it deep search instead of deep research, which OpenAI calls their version. And this is really a great example of agentic behavior, meaning we know what the workflow for doing a bit of basic research is. You find some sources, you compile what you read across them, you draw some conclusion, and then you structure the output.
And you research a number of times as well.
And you research a number of times. And so we can describe this quote-unquote workflow in a very well-defined way. And so that is an agent. It's a very simple agent, but it's still an agent. And it's an agent that everybody has benefit from. And people will ask questions like, give me a breakdown of the performance of this company financially, blah, blah, blah. And it'll generate a really, really nice report for you. So
the whole traditional market research, can you do a report on a market entry strategy to UK for Vattenfall?
It could even be, could you compile me a research report on what I need to think about when buying running shoes?
Exactly.
It'll teach you everything about foot arches and stuff like that. It'll make research on anything you want.
Yeah. And the core topic then is that it thinks it through, and then it goes out and can more or less search for those things, and it can produce the report reference to what is its sources and how it's So this is very powerful stuff for a lot of different disciplines.
Yes.
In normal day life.
For sure.
Would you say Grok 3 is a incremental improvement or more of a step change improvement compared to OpenAI and Gemini?
I think they're still playing the catch-up game on some fundamental stuff, but there's so many things to appreciate, and applied science is just super important. It doesn't matter that somebody has some secret weapon in their lab down in the basement somewhere, and I'm sure OpenAI has lots of that. But the fact of the matter is that Grok 3 is out, and it's just so good, and people can use it, and they know how to use it. So I would say in terms of usability, it's a huge leap. It's just so good for the user.
But do you think it's better in terms of define usability from your perspective then?
I mean usability in the sense that it feels like it knows what I'm asking.
Okay, the way you connect with, what you had in mind, for you, the way your brain is working, it nails that.
I mean, if I ask OpenAI, look, I'm starting to learn how to cook. And I also have my system prompt, so OpenAI knows that I'm a 40-year-old engineer, I'm not stupid, and I'm trying to ask it how to make lasagna. And it's like, great question, let me do this for you. And I just find it so patronizing, and it's just a lot, I don't like it. Grok just is like, here's some cool ingredients, I think this tastes good, it's a reference from this recipe, see if it works for you. And I'm like, actually, I don't know how to fry, can you tell me that? Sure, it'll give me the answer. It might just be personal preference, or for sure it is, but
I think this is very important, and I think it was even Elon who said it. I mean, like, we will need to find the LLM that suits our tastes. I think that is quite telling, because I mean, like, you have a very acquired taste in both in music and and how you are, and also in how you converse.
Yeah.
So that is obvious that what is better or worse then becomes a personal preference somewhere here when it's like on the micro percentage benchmark, better or worse.
I think we're creeping in on sort of design topics that designers are really passionate about, so we probably shouldn't step on their toes too much, but there is an aspect of both learning a tool and having it adapt to the way we want to work. And I think Grok 3 hits the sweet spot. But
Louise, have you played around with it, or
not with this one? But I just came to think about the fact when you spoke about tone, just not only in this one specific, but like you said, you need to find the one that sort of speaks to you. And I remember in my first sort of conversations with ChatGPT when they came out, and I was sort of thrown off by it because I thought it was so chatty, and it was so trying to. I don't know, please my ego. And I was like, I'm not here to be pleased. and it really, I mean, it took me a while to find the ones that weren't as
And I
chatty.
remember we had Luca on here, and like the whole discussion, which one is the better, which one do you prefer coding with, Claude or ChatGPT? And then he's like, I guess ChatGPT objectively might be better, but it's too verbose for me. That was the end game, right? So he preferred Claude.
But here's a question though: have the models actually regressed? Meaning, remember when first what was Microsoft's version of GPT-4 called
Sydney?
Sydney.
Yeah.
I feel like the first versions of GPT-3, 3.5, and 4, and Sydney, and all these were really, really good, and then quickly they were locked in, and then they weren't good anymore. Is that just...
what do you mean with good then?
I just meant like...
they regressed.
Funny or...
So they cut off their token space. So what do you think happened?
Yeah.
I don't know. I just feel like they got more canned answers.
I mean, remember the initial, failures of Sydney was kind of amazing. It actually became angry with people.
Yeah.
It really, you're stupid. I'm right.
Yeah.
You never see that today, and that kind of non-PC kind of behavior is
Got
really
canned.
not okay today, and you don't see it anymore. But it
Maybe
did
they are really, really, how do you call it when you take antidepressants? So you just sort of flatline your mood swings, and that's what they've been doing to them.
Oh my God, there's too many analogies to be made here because I think antidepressants affect your performance in many other respects than just that.
Yeah.
And
Good point.
we were talking about how there are some models now that have been
flattens out.
uncensored and they have improved in benchmarks because the censorship was removed. And it's not obvious why they would be better at math when censorship is removed.
But have you tried Grok?
No, not not Grok 3. No, so I'm not a paying user yet, but I probably will be. Yes.
Yeah,
so.
I'm intrigued now. You sold it.
But it has image generation too. I forgot to mention, and you can upload images. I think I feel so bad about doing this, but you know how old people will take a picture of their screen and then paste it into a Word file and then zip it and then email it to you instead of just cutting the text. I did something similar. I got what was it? Some kind of Kubernetes error. No, a Rock M error for my AMD GPU. And I just took a picture of the screen and sent it to Grok on the phone, and it did OCR and debugged the message for me. Cool. I felt really sinful for doing that. But OCR is better in these models than real OCR models.
Yeah. Oh,
that's crazy. But there's so many more things to talk about here, because one big topic here is I guess right now the biggest supercluster is the one in Minnesota. Is
Memphis.
Memphis. And we are talking 200,000
should we go
CPU.
to that topic?
Yeah.
I think the speed issue here is a really interesting one, and it's connected to the data center that they built specifically for Grok 3 and what it's been trained on. And should we start with the data center issue then? But I think the whole thing connects to speed in some sense. I can start to give some of my thoughts here, and I think this is actually what makes me really, really impressed with how they were able to develop Grok and what will set it apart in the future. So thinking about this, Elon was late in the game of LLMs, early in the game of self-driving cars, but not in LLMs. And actually XAI was started 1.5 years ago, summer of 23 or something. And they built the first version, Grok 1, Grok 2, and 1.5 years after, they're beating all the top AI labs in the world, including OpenAI, Google, and Anthropic, and so many more, which is incredibly impressive. Then if you take a specific thing like the data center that they built, so they recognize they need a shitload of GPUs to do this. And you mentioned that as well, Henrik, but they went to the normal kind of infrastructure providers and said, we want the data center to hold 100,000 GPUs. How long would it take? And they said, about 18 to 24 months. I said, no fucking way. That's too slow for us. We will be dead if we wait that long. We're going to do it ourselves. So what they did then is they tried to find an abandoned factory somewhere.
They needed a building.
So they found an old Electrolux.
Yes, that was a Swedish connection.
So there's a Swedish connection.
It's an old Electrolux manufacturing plant, so it's more or less Swedish.
Basically Sweden.
We can take the credit for this.
So we as Swedes can take some credit here.
Okay, so they found this building, and then they basically in 122 days went from the building to a working data center where they can start training, which is unheard of. But the other thing that is, besides the speed of being able to do this, which normally would take 2 years, they did in 122 days, is the scale. So no one else has actually built 100,000 GPUs that operate in a coherent mode. And if you want to do inference, it's kind of easy to scale up. You can have large number of data centers that don't need to be connected to each other. They can be distributed. No issue.
Training.
But for training, they need to be connected and they need to communicate to each other.
When we say connected, it means that they have to work together.
Yeah,
it cannot just be, stuff being distributed. They have to actually think and use.
And for every kind of training batch they have to send the gradients to all other GPUs in kind of all reduced ways. So they have to communicate a lot. So extreme bandwidth demands. And let's go a bit technical. I'm sorry.
There's one more thing here that I think is super remarkable about these it's not just XAI, but it's all sort of companies that try to do anything over 1 billion parameters, is that you almost always only have one chance to get it right. You have like one giant training run and you do one pass through the data and that kind of stuff. It's not like they can distill smaller models from the big models.
But they can interrupt it during the training though.
You're right. But it's not like they start from scratch.
No. But they do tweak during the training quite a lot.
For sure.
Right.
But I heard the long format with Lex Friedman, and they had the word for this, the do or die run. What do they call it? Like you're really betting a lot of money.
Imagine it's not like they go wild with the architecture, right? I mean, there's some commonalities and stuff, but they try to do some stuff there. And if they make a bad bet and halfway through the training, they're like, you know what, this was maybe not a good idea. It's not like you can start from beginning again. You lose months.
And the story they did on Lex Friedman was like they were calculating and say, you know what, Sam Altman at one point bet the whole company on okay, now we have tweaked. Okay, are we ready? Do we feel like, are we going to press the button now? And now if we do this now, this is billions burning. Or millions burning at least, right?
Yeah.
And they had a word for it, like the run of all, LOL. I can't remember. There's a Silicon Valley saying, like the death run or something like that. It was funny. Very Silicon Valley-ish.
Just go through the whole kind of training. I think is cool with the data center. So there's a lot of innovation that happened during these 122 days. It's not just that they actually did it so quick. They did it in a very innovative way. So the whole communication, normally when you have these kind of GPUs, they use something called InfiniBand to really communicate super quickly between the GPUs, but they didn't do that. So they collaborated with NVIDIA and used something like normal Ethernet, it's a Spectrum X Ethernet kind of thing, which enabled them to communicate so much faster than they otherwise could. So that's one big innovation. The other thing, was that they actually use water cooling for the GPUs, and that's normally not used. And you have normal air cooling, except TPUs in Google. But still, that was a new innovation that they had to fix. And
the whole thing is cooled, water cooled.
And then, how do you do that? I mean, they need to have this kind of big factory building, and they need to put a shitload of containers, beside it to basically fix the water cooling to make that work. But not only that, then if you actually have 100,000 GPUs using the power grid of the state in Memphis, that's going to disrupt the whole power grid in the state. So that didn't work either. So they had to come up with a solution for that. And then they took all these kind of power walls that they have anyway for Tesla cars and Solar City and just put a shitload of those kind of containers on the side to basically balance out all these fluctuations that you are seeing during the training. So that's another innovation. And all of this happened, and we're able to make them build this kind of the biggest training data center ever.
And you can find a 3-minute clip where Elon is sort of sequencing the problem. From the building to when you get to the building, we needed to have all the containers of power next to it. And then we needed to have all the containers of cooling next to the building. And he actually mentioned a stat. They apparently used a quarter of the total fleet of mobile cooling in US. A quarter of what you can find. And then the power wall, and then they had to recode the power wall for this problem. So there are many things they used to say, it's like, you solve one problem at a time.
The scale of this is so insane, and I don't think people understand the scale of things happening here. And what's even weirder is that after a soon time they said, this is not enough. We're going to double it to 200,000 GPUs, and they did that in 92 days.
Yeah, but okay, so one stat here. I heard it, and you can explain this better. Is this facility the first one where they actually run 100,000 CPUs concurrent? So even if you go to OpenAI and some of the other ones, they tap out at 50 or 60,000.
20 to 30,000.
20 to 30,000. So it's a magnitude of 3 times more complex networking going on, at scale.
Yeah.
And so this is an engineering feat in its own, right?
For sure.
Nice.
Yeah.
It's cool. Yeah. And they're aiming for 1 million GPUs now. So that's the next step. And I mean, then when you think about, the other big thing a couple of weeks ago was the Invest in AI initiative from European Commission. And they were saying we're going to invest 200 billion euros, which is actually a good thing.
That's awesome for Europe.
It's a bigger investment than we've seen ever before. Before it was like a few billions. Now it's 200 billion. It's kind of nice. But they said, we're going to build 100,000 GPUs. And, for EU to do that, it's going to take years, probably. And in a couple of years, where will Colossus, as this data center is called, be?
Yeah.
Yeah, but and if you want to contrast that with EU, I saw someone make a comment on it. How can you make this engineering feat as a committee of 50 different partnerships?
Yeah.
And contrasting that to a team of super SWAT team led by Elon Musk going bananas. You cannot do this as a committee. You cannot do this type of engineering as a committee, I don't think. That's one of the main problems we have.
I think you can do it for maybe some topics where there is no rush, but even there, like in fundamental physics and that kind of stuff, we've seen a lot of reasons why these things sort of pick up. But we've seen precedent for projects that have run for 3 or 4 years and have become outdated during that period. And it's not like it's slowing down now. So building a data center now and then hoping that something comes up in 3 years from now is not tenable.
No, but the engineering feats we're talking about, if we follow the history, how was the nuclear bomb invented? The Manhattan Project. You take the brilliant minds and lock them in a desert, and and they can't move.
Yeah,
right?
but I think
so. I don't think you can. What I'm trying to say here, this type of engineering feat requires an extreme focus from the right people and cannot be run as a committee.
Yeah, definitely. I think there's a lot of point to that. But another thing that could be interesting for me to ask you then is, what you're talking about, the Manhattan Project or similar things, or
the CERN. They're comparing this to the CERN project in Europe, which is interesting.
But I think it's a difference between being the front runners, the one who pushes the boundaries of what is possible, who achieve these things that nobody said was possible to do in such a short amount of time, and just a feat of sort of gathering up a quarter of all the water coolers that's even exist. But there's also the second part of sort of the second gang on the ball, which can learn from the forerunners. Then they're not going to compete with being, the ones who pushes the boundaries, but they can be the second runners up who do things smarter.
There's two different discussions here, because I truly believe that you can have you can succeed if you find your niche and your approach. And therefore, I'm not talking about that we are second on the ball and therefore we can lose. So that we can find our niche for a European data center for sure, and whatever that is. But then you come to how you go about getting there, and this is when I say it cannot be run by committees. I'm not saying that we cannot find a good
my question was not
value proposition. It's about we need to find a format how this works to be able to do this work.
Yeah, of course. And my question was not so much if it's possible or doable, with a committee in place, because I think that's always a hard time unless you're doing things very slowly. But more on like what could the value be of actually being, the second runner-up.
We have the innovator's dilemma here, which is actually partly applicable, I think. And I think it's stupid for Europe to do the frontier model development and try to compete in that. Yeah. We could be actually winning, using them, finding the application for that.
Yeah.
And I think that would be amazing if we actually did invest in that. And then potentially, they call it, if we compare the big Stargate thing with $500 billion in US to invest in AI, Stargate was basically three main people or companies that going to drive the whole work, which are commercial private industry companies, the Oracle, the OpenAI, the SoftBanks that's going to drive it. They have proven track record. They know they can build it, and they have a small set of companies that's going to drive it, and they're probably going to succeed in some way. If you have this kind of committee that you speak about, Henrik, and then saying we want to have a more inclusive approach.
Going to have 50 actors, and no one has done it.
No one with a proven track record, no one that really is accountable either, is super hard to orchestrate. So if they are going to go into like this kind of idiotic race, trying to compete in building these kind of frontier models, which, how can they compete in terms of speed when it comes to Grok and what we're seeing there? But what if they instead compete of using it?
Yeah.
I mean, and that would be an amazing thing, I think.
So there's one thing how you raise the money. And now you need to raise the project. You need to raise how will this work, And then you need to raise, what is our competitive edge? Where are we going to put this money towards?
But I mean, it's always so much easier to bash on things and to say like, we can never do this, or we can never.
But
this
we
is not
can.
possible.
My argument is we can.
But then turning the question towards you, who come from, you represent different fields in this area. What would be the smartest way then for Europe to go about? How do we make the most out of these kind of money that's being poured in? How do we utilize the thing that is our kind of...
Can we stay here a little bit? I love this question. It's a good question.
Thank you.
Do you want to start or should I start? Or should you start?
Yeah.
Robert,
I got
how
a
would you
sense
spend
from
the
Anders'
money?
answer, and I, if I understood it correctly, I agree that there is just such a untapped potential in the way these technologies are applied.
Exactly.
That we could be making all the coolest applications, programs, services, and everything. And then the fact that the weights are pre-trained somewhere else is sort of immaterial in the grand scheme of things. And I think that the engineering track record required for doing that kind of stuff already exists here.
Yeah.
Not building data centers, but building cool tech companies. I mean, we have that. We have all the good universities and everything. So it would be neat to see. I don't know if there is something that needs to happen with the funding, but obviously the money exists, and then sort of deciding how to
format the structure.
put that into the right companies is a sort of another matter. But I think the focus should probably be more on applications.
And what is your take?
I think, as we said a bit before, if we take a tech company, that the one that actually have found a lot of value from AI, and see how much do they invest in research versus engineering. That's one question. And obviously, I would say they basically invest 10 times more in engineering work than in research work. If you then see how Europe has done it traditionally, they basically only fund the research and very little investment in terms of engineering. And that's a really bad idea. And if you just take the previous Euro HPC investments that has been poured billions and billions of euros into, they couldn't give the compute away for free. They literally said, you get compute in this kind of AI clusters for free for companies that want to use it, and they didn't want to use it. And why?
Why is that?
Because they were supposed to use it for innovation purposes, not for production purposes. So, okay, let's say you actually are using it, you build a model, and then you say, okay, I wanted to put it in production. Oh, no. Then you have to go somewhere else. Then you have to switch the whole environment. Then you have to buy your own or go to the cloud or something. And if you look at the cloud offering and the functionality they have there to do the serving, but also the training, it's insanely much better than what the Euro HPC is doing. So I think this is a twofold. One is simply the miss out on investing in engineering efforts, which is really the hard part. It's probably less than 10%. It's more close to 1% of the effort is the research part, and so much more is needed to be spent on the engineering part.
And then you can actually lead on to that. You need to have a product mindset here.
Yes.
You need to have something that is usable, useful, adoptable. So if you do something that is research oriented, well, your offering is very niched to researchers who know what they're doing. But it's not easy to flip that product. That is not a product ready for small, medium business or public sector. So if you take those things, you get to a couple of things. Okay, we need to spend this hundreds of millions on engineering, doing something cool with a very clear product and a very clear use application. We need to figure that out. You said it yourself, it's an application oriented. We joked about this in the Christmas episode, and we say, you know what? Europe should use the frontier model to distill out baby models for Europe. We should use those fun. We should applaud these crazy investments, use them to our advantage, and then basically flip it into with our data for whatever domain that we want to be good at. Automotive, hint, hint. Transport, hint, hint. And then we build the world's best, baby model for very clear industry domains that is suitable for the profile of European industry.
Yeah. I think one thing that's worth reminding the audience of is that the innovation, OpenAI has done tons of innovation, but the thing that was very specific about ChatGPT was the interface. It was a product innovation. It wasn't a technological
It was not a
innovation.
technology. It was not a research
That
innovation
could
at all.
have, in principle, have happened here in Europe. There's no reason why somebody couldn't have launched a really sweet chat service from Sweden.
Yeah,
Isn't that
it was
interesting?
easy to use.
Yes.
And we
utilize.
joked about this, and we had the joke like, "There's no research in here," and that no, the research was in transformers, and then so no, the research was not in transformers. The research was what the transformer techniques are based on. You know, you can go on forever. So what is research? What is product? And what is then even UX? We had the guy from Bonnier Media, and we had a very good argument. And he was distinguishing, it's all about UX. You remember that? Yes. But it's some truth to it, right? Sure. And then, you know, if you take that, it's very interesting.
Yeah, but I mean, you can tie that into both what you were talking about the engineering part, which for me, and I'll say this from my perspective, but you have the research part, which is, you know, what's the ideal, and then you have the engineering part, which is how do we make this work in the real life, in the real world of things, and that's sort of similar to if we talk about then the user face of ChatGPT or something similar, because something is only bringing value or making a shift of something when it's actually usable.
Yes.
And you can use the ability not only to the to everyday people, but also the usability between like a researcher and an engineer, or a researcher or engineer to a product owner or whatever.
Having this kind of engineering first mindset, I think, is so important. And actually, that is what Elon is doing all the time. He's thinking, what should I use it for? Then he goes back and see, what do I need to research to be able to make it work? If it's a full self-driving car, or if it's Grok 3 for Twitter or whatnot, but it's always putting it in production super, super fast.
Coincidentally, the approach Microsoft took to designing their latest quantum processor.
Can we go there?
I'm just kidding. Let's not go into that one.
That's a example of the opposite. Which is kind of interesting.
Yeah, but we went down a rabbit hole starting from Grok, and we took Grok into the engineering feat, and from the engineering feat we sort of reflected on how should we spend our money in Europe, and I think it's a quite nice turnaround. I mean, like, do you have anything more to say about Grok if we flip it all the way back?
Oh yeah, a good question.
Anything else we want to sort of highlight in this whole?
We don't know. Elon has said that he's going to open source Grok 2, right? So for every version that he releases, he open sources the previous one.
Good.
We know that when he open sourced Grok 1, it was basically impossible to run because it was designed for their big, huge machines. And if I were to suspect they didn't design the models with charitability in mind, not that they don't mean to be charitable, but they're not meant to run on your laptop. So, well, in any case, they'll release that. And what else?
No, but I think it's a good point. I think we should spend a couple of minutes here, like on the question of what is the future of open source AI models. And if we start what you said there about Elon, because he's been promoting like open source from the start. He actually did start OpenAI on that specific purpose, to put the latest type of AI in the hands of everyone and be open about it. And then he left, and then Sam turning it into a private for-profit company. But still, we can see also now actually Elon, which in some sense is a double standard here, saying Grok 3 will not be open source now. What he basically said is the second to first model will be open source, but not the first one. And also he's not, if you go to the thinking mode that it has, it shows a bit how it's thinking, but he said basically, we are deliberately hiding a bit how it works to avoid being copied. Because DeepSeek and others will do the same again and just copy from it. And we know DeepSeek, distilled from OpenAI. And he wants to prevent that. So there is a commercial reason to not open source here. And I think there is a regulatory purpose as well, but still. We made a prediction, I think, before, saying frontier models will not be open sourced, but other models will.
Yeah.
And I think this is actually what we're seeing here.
Yeah.
So even Elon, that is a super promoter for open source, is not open sourcing now the frontier models.
Yeah, and the prediction goes, we will have in the end 3 or 4 real frontier models. And based out of that, the rest of us will build product distilled using open source approaches?
It's very hard to say what's going to happen 5 to 10 years in the future.
Yeah, that's true.
Because imagine we have models that are good enough that can run on personal devices. Then maybe frontier, that distinction won't exist as much.
Exactly.
There was a little
But don't you think
movement.
there will be a few really, really huge models that will never run on a
maybe
phone,
they will
over
be the
phone?
God models. Who knows?
This will be the
exactly,
God models. They will exist, but for practical purposes.
But I just want to say there was a little run on Reddit recently. You know, Sam Altman went out and did a poll on X and they said, "Do you want us to open source a cool model or a telephone model?" And everybody's like, "Oh, I want a telephone model." But we can distill a telephone model from a cool model if we want to. And people didn't get that, so they started voting for the telephone model. And everybody on Reddit's like, please go in and vote. And so, you know, with the Reddit flood, they managed to turn the tide of that. But it's not like OpenAI is trying to be charitable. I mean, he even admitted we sort of messed up on the openness part, and now he's trying to
what is the cool
damage controlled.
But that was a big change in their approach.
Yeah.
And they certainly went from open to closed, but now suddenly Sam is saying we may have gone too closed, right?
But let's move into that as a news section. That is a segue then.
But this is the open source segue.
Okay,
right?
yeah, this is the open source.
Yeah, we
This is
are
the
there.
open source. Yeah, I'm getting it. Sorry.
So what do you think? You know, was it the DeepSeek that forced Sam to change direction here a bit? Do you think, or?
Yeah, it was probably the straw that broke the camel's back. I think he's realizing that people, you know, you can take bad publicity for quite a long time, and there are some politicians that are masters of that, but OpenAI is not a master of that. And bad publicity now has sort of caught up with them with the openness thing. Yeah. And when DeepSeek came out and everybody got nervous and said, well, look, open source is just as good. I think he just wanted to sort of fix their the damage that had been done to their brand. Yeah. I don't think he's being. This is not for the greater good. This is a PR thing.
And this is also a marketing strategy thing, and we can talk about it. It's if you're the front runner, you want to build a moat in one way, and if you're the second in the game, you want to kill that moat in any way you can. So I mean, like so of course, then open source is a way to take away their competitive advantage. In the end, my prediction is that, I mean, like, let's call them God models to really show that this is something very, very different. We will have very few of them, and maybe we'll tap into them at some point. But I think for practical purposes, I think the whole edge model or the small model is more feasible in many cases. Yeah. Because of the cost of running them, etc.
What is the distinction, again, I forget what it's called. Open source is when the project is open and people are able to commit and partake in the community of it. And what's it called when the source code is available, but it's not open source?
So when it's more transparent?
We talk about open weight is one.
Yeah, well, open weight is one. I'm thinking more like, you know, how Chrome is not really an open source project just because the source code is available.
It's like GPL, the GNU.
No, it's more like only Google can really commit to Chrome, and then everybody else can clone and do their own fork of it if they want to, but it's not really an open source project. It's Google's project. And it's the same thing here where, I mean, these companies are not running it like open source projects. It's not like Debian or FreeBSD where anybody can be a part of the project. And so Llama and all these other things, they're not open source projects. They are things that are put out into the wild to undermine the competition as part of some kind of strategy that we're not entirely privy to. And, you know, in the minds of the people that are doing it, they have an idea of what they hope to achieve. And we don't have open source AI projects really anywhere.
Meta is still trying to go that line, but I think they will change soon. I think during this year, Meta will also stop producing their frontier models.
But I get your point. Open source, yes, but can anyone commit to the source code?
Or contribute or change or do.
This is the real line.
This is run AI projects like that, I think.
Like the Apache project.
Yeah, something like that.
You know, it's not.
Yeah.
Is even Llama that? I'm not sure.
Well, maybe we can talk about that at the end, because one of the papers I want to talk about is about a model that didn't require as many GPUs as these super giga models require, and what maybe little companies can and should be. Yeah.
Okay.
All right. So on the open source topic then.
Yeah. What's the future?
What's the future? What's our predictions? I think I stick with my predictions that we will have some few frontier models, but for the practicalities, we should be focusing on distilling out our own models, and then most likely they will have an open source core. And this is how we build cost-effective.
There's one more weird thing happening when it comes to open source, and that is that a lot of innovation is going from open source to these companies. So all of the thirsty Redditors that want to run these giant models on their 3 gigabyte old clunker GPUs are coming up with really cool hacks for making things run better. They're the ones that are sort of pushing for smarter quantization methods and other stuff like that.
So the open source approaches will help us distill out more cost-effective and energy-effective approaches.
I mean, it's not the only source, but it's surely a pressure.
Yeah, and it becomes a pressure of, memory usage, storage uses, bandwidth use, all this.
But just thinking, okay, future, do you think we will see, let's assume that we have 2 trillion parameter in the latest, or in GPT 4.5 being released soon. That's obviously super expensive to run anything on, and probably if you build a product that have 1 million users, and they all make use of this model, it will be far too expensive to make use of such a big model, right? Would you think that upcoming models, coming years, will have even bigger number of parameters, a large number of parameters than this, or what do you think the future will be there?
I think they'll go up and then come back down again, because it's easier to scale up certain things, and then once we learn the tricks, we can bring it back down again.
But potentially there will be models that even if you use reasoning tricks, which I'm really excited to speak more about soon, there will be some things that is super expensive to train and use for anyone. And Elon, when he have 1 million GPUs in their next Colossus version, they will train something that is, really, really awesome, but far too expensive for most companies to build a product on. Yeah. Right?
Yeah. I don't know. I mean, we can look at the price of hard drives over 40 years. And maybe the price of compute will take 80 years to get there. I don't know. It's just very speculative. But with regards to open source on its own, I think there's so much cool stuff happening in open source that people will keep themselves busy. So if we tie it back to like the SVT stuff we were talking about before, the little fun LoRa's that we're making, the stuff that we're doing with image, the stuff that we're doing with text doesn't need all those frontier models. And so I feel like there's space for open source to thrive and grow.
Yeah, I mean, that's a second line kind of models that you spoke about, right? And that will be what we really should spend time on, right?
And this ties back to, we had Anton Osika, founder of Lovable, and we discussed with him, what to care about and how to build a great AI product. And he was really putting it, at some point in time, yes, the model is important, but I need to really focus on the engineering parts and making the whole thing work and the UX work. And that is way more important now to get to useful performance than the actual percentile of the frontier model versus a mini model.
Yeah.
And I think this is what we are almost, the headlights is rising to us and we get the shiny light. So the real problem is in the blind spot, which is build a fucking awesome product. And then in that sort of, that whole brick wall, the model is just one brick in the brick wall.
Yeah.
And I think this is what we need to figure out in Europe, that, we need to be really fucking good at building the brick wall and not only staring at the frontier model. It's one brick.
I see Goran is playing around with Grok 3 and we're doing some deep search.
Is it making a research report for us?
Yes.
I think it's just pretended that he's thinking.
No, it's thinking about something. I guess we'll find out soon.
There's confusion in the numbers.
Robert, you had. Let's go back to the report when it's done and then see what it came up with. What's your question to it?
So, if Grok would have a mission to make Europe leading AI basically by 2030, how would you do it?
Oh,
that's a good report.
Yeah.
Send it to the European Commission. When you're done.
Solved it.
Charge it as a center.
It's kind of. I've used these kind of deep research things from OpenAI and Gemini, and now deep search here as well. And I haven't used deep search, but still, it is kind of impressive how you in 20 minutes can do something which normally take months to do. Right? Otherwise.
Yeah, I read this. This small study from BBC, I think it was, where they had done, very old-fashioned deep dive into how different AI-supported news outlet, how they compile their news, and if they're correct or not. And I don't remember the precise numbers, but it was quite a large number where they were, making stuff up when they were sort of summarizing the news, and I think it was maybe even half where there were, errors, or where they didn't, they changed sort of the tone of the news, or they changed sort of what the angle was.
Changing the angle. No journalist is changing the angle ever.
No, never. But I mean, it could be troublesome if you read sort of what you think is a summary of a BBC News article, and you expect certain things, and then you get something else.
Yeah, that's true.
I thought it was just kind of interesting, especially today when we get so much sort of compiled information in that way. And of course, that maybe ties into how Perplexity or other similar services are being used today, which maybe ties into how.
I think we should read out, what Goran just did, and he doesn't have a mic here, so I can read for him potentially. But you basically asked, some kind of question about, how Europe can win in 2030 or something.
How leading can be the leading in the AI race by 2030?
So sort of the question that we answered or asked.
And the hypothesis is if Grok will do it, and if it has the mission to win.
Oh, okay.
Goran with leading questions here.
So you need to win.
Okay, so I'll go back to the first part, and then I'm just going to read out. But okay, key points. Europe needs to boost AI funding. Okay, spotted on that. Attract talent. I think actually we do have kind of a lot of talent.
I think so too.
Streamline regulations. Certainly agree. Lead globally to win the AI. To win the race by 2030.
It's very important. You need to have a vision to win.
Yeah, but I think it's actually a bad mission to have. But that's another thing.
It doesn't matter. It's just a mindset.
Yeah.
Must invest in infrastructure and foster collaboration. I suppose collaboration within the EU. Okay. A unique advantage is Europe's focus on ethical AI. That's a unique advantage in becoming the world leader. Okay. Yeah. Which could set global standards and attract talent. It could attract talent for sure.
Yeah, and it could actually be a good point. Okay, can you scroll down?
High level so far.
Okay, steps to win. Boost funding.
Okay.
Wow, doubling the public AI funding to 2 billion yearly by 2027. Create 50 billion European AI investment fund to attract 200 billion in private investments, matching US levels.
Yeah, okay.
Makes sense to match US levels. Launch a European AI fellowship with stipends to build custom AI curricula to train 1 million professionals. This I want Louise to talk about for a sec, because she has spoken on other podcasts about the idea of creating AI courses in university and whether that's a great idea to sort of speed up AI professionals. Sorry, maybe I'm getting ahead.
Do you want me to do it now? Continue reading this one then.
Let's pin it and remember to get back. What is the best way to get people good at AI right now?
Okay. Good. I write it down.
Streamline regulations. Oh man, that's like beating a dead horse right now. Build infrastructure. Invest 10 billion, very specific number, in computing centers for 3 exascale computers by 2030, and develop a European AI cloud platform for secure resources.
There it came. We need our own cloud.
It's for inference. That's unspecified. Maybe later for inference. We don't know yet. Foster collaboration, AI hubs in major cities, cross-border projects to unify efforts across 27 member states. Set global AI standards. Okay, still pretty high level so far. Comprehensive analysis. Let's just check maybe the first one and see sort of current AI strategies, focus, excellence, and trust. Recent initiatives include Invest in AI initiative launched in February 2025, mobilized 200 billion. Okay, it's found the latest one.
Yeah.
Including 24 gigafactories. However, here's the detailed plan.
I think it missed the point of engineering.
I think so too. I think you need to be more explicit on that fundamental topic.
The only one that sticks out here is the exascale supercomputers that it thinks.
And only for innovation purposes. Right. Stupid. Okay, I'm still.
Citations.
Yeah, it's much better than perplexity.
You prompted it wrong, Goran. That's what happened.
Anyway, should we move to another topic?
Yes. Okay. Which one should we take? Should we take your topic then? And let me see if I can phrase it properly. But something about, what's the best way to learn, how to use AI today? Or how would you phrase it, Louise?
Yeah, well, I think it's a double-sided questions, because we were both talking about sort of how do we bring forth, or do we bring forth people who are sort of on the edge or on the front when we talk about AI development. And obviously, there we have the research field, and obviously there's a lot of stuff happening there. But if we then take the other side of the coin, like how do we make the most value out of it? How do we make Europe something that's competing on those levels where we see that there's
embracing it in our enterprises?
Yeah, exactly. Where the action happens. How do we make money out of it? Which of course is the sort of the end line here. And
sometimes societal gain as well.
Yes,
it's okay.
of course. But usually, those two goes hand in hand in one way or another.
Agree.
Yeah. Either you work smarter, you make better systems, you do all these things, and then you.
But for public sector, it could be other things
Yeah,
than
of
monetary
course.
gains. But still, I see your
definitely.
point.
I agree with you. And then I think if we're talking about the regular sort of educational systems with the university and stuff, then at the least you have a 7-8 year sort of frontline to when people if we were to decide today, yeah, we need stuff, then it's say 7-8 years at the least to get those people out into the industry again. And then we're talking about junior people. They're not even dry behind their ears yet. So then how do we make sure that we get people the right competence and the right stuff so they actually learn? And then of course, like you're talking about, then we need to make sure that people actually doing the work today get to know how to handle the different tools and the advancements and what's actually possible. And I was actually thinking when you said that the team that you work with today at SVT is a really small one. And I find that so interesting, because the smaller you make the team, of course, then you have to make sure that people, all of the ones in the team, knows what they're doing. You can't have these, humongous teams with 25 data scientists somewhere doing some sort of work. And I think that's a super interesting sort of field if we're talking about how to make sure that more companies today in Europe get to use this kind of technology. We need to bring in people who sort of spread out the knowledge and get people to do stuff. I don't know who said it, but when you talk about engineering, like putting it out in a production part, that is, and I thought about that when you said these huge models that you were talking about from the start, and you sort of at some point have to push the button, do we know enough? And the same thing is on a very, very small scale when you talk about companies and industries. You have to at some point be like, now we just have to try it out. We may not know everything, we may not have everything in place, but we just have to try it out. We have to start somewhere. And I think that's where most of the learning actually happens, just as it is when you talk about, huge projects with scaling or learning or developing these kind of models. It's not until you actually see what goes wrong that you can be able to adjust, and you do something new and then you learn. And then the other ones coming after, they're like, well, this is the trouble that they were, running into. How can we make it smarter? How can we be better engineers so we make sure that the production, the actual results of something gets better? So a very long, maybe very broad answer, but I think it's...
And the bottom line then, the university will fix a small part of the problem, but you're alluding to that we need another type of adult learning on the job, experience learning.
It's so obvious when I think about it, but I had
obvious.
just never considered the sliding time window of universities. Like, do we have like an AI course? Yeah, then they have to go the course for 2-3 years. So we're still like 4 years away from getting those people. And then, like she said, they're junior developers too. So we need to use the people that we already have as well.
Isn't this an example of, trying AI versus like building AI? Sure, we need to have education that brings out like super, technical people in what AI is, but the big value isn't from those people, I would say. The big value is when people that are domain expert in whatever kind of field there is start to use AI. And that is when I think what you're doing as well, Louise, is really upskilling people to have the level of knowledge they understand, what to use it for and what to not to use it for, and how to do that properly. And if we can get people to just be able to use it properly without having to build it, I mean, it's similar to the Europe versus US kind of thing as well, then that is really the valuable thing. And then you don't need to go like a university course for 4 years. You can take a smaller upskilling course rather quickly, right?
But there's a deeper problem here, because on the one hand side, I fully agree with you that we then need to focus on adopting data and AI in our core operations. So that is not the same as having another AI researcher out there. The key problem that I have seen that has worked extensively with enterprise is that a lot of times we have a fundamental way of organizing and processes that were designed in an analog context. So that education is not only about using AI, but the education is, okay, maybe I need to have a cross-disciplinary team. I need to have this prompter expert. I need to have a product owner. So there is an upskilling that is not related just to using AI, but it's the context of organizing in an agentic world, maybe. So I think this is all about user adoption, but it's actually about leadership, and it's about organizing things slightly different. Otherwise, we are putting AI onto analog processes, and I don't think that is really the productivity frontier either.
That's not really a new problem either. Hasn't that been sort of around for quite some time?
Yeah, but we never solved it.
No, we haven't solved it, and now it's maybe it's on steroids.
No,
even though we've been
discussing that exact problem. I've been trying to sell to that problem since Data Innovation Summit, but ultimately we have this divide that people that are setting the organization and designing the processes are AI illiterate. And I'm not saying that they need to be engineers, but they need to understand what does it mean to have a cross-disciplinary approach? What does it mean to have a product-oriented approach?
Yeah, but I mean, we had a discussion, and I think I asked you about it, which was, if you want to get started, what's the smallest possible team you can have, and what does that consist of? And we spoke about, which again ties into the fact that you need the engineering part. Yeah, because of course you need the full stack engineer, who preferably knows, all the ins and outs of how your system setup looks today, about what do you need to think about security wise or governance wise, or whatever it is, all those bits and pieces about how does our setup look, what makes it work, what makes it fail, what makes it blow up. And then you combine that with somebody who actually knows, not necessarily a data scientist, or rather not, but rather somebody who's a Gen I developer who knows how to build programs on these new technologies. And when you combine those two, and then preferably with some sort of AI product owner, we said, right? Then you have like the smallest task force that you can have, but still have the capability of doing stuff that works.
Yes.
Would you agree?
Yes, but it's such a deep topic. I can speak about this forever. Just a small comment here. You can think about, should you optimize the existing business processes that you do have, or should you invent new business processes? And of course, the big value comes when you start to transform the way you work. But I wouldn't, say it's a bad thing to optimize existing one either. That's actually a good thing to start with, because it's so slow, it's so hard to change an organization and the way they're working. So don't be afraid to start the easy way.
I always do.
Right.
And then you have a strong point there, because it's also about, if we think about this as learning by doing is the only thing that will work. So maybe then, okay, I give up. Let's now try to improve our analog process with the wrong organization as a project. Yeah. And then we realize by learning that, we maybe need some other team members here, et cetera, et cetera. Yeah. So I see your point, that actually don't get hung up on that. Don't make the whole problem too big.
It's not the first thing you would start with, I would say.
No, exactly.
I get that point.
I have a very, very tangible sort of example from that, and that is when I go in and I try to set up, the smartest way of making sure that people learn stuff in their work environment. And people are always looking for that sort of, magic bullet of just give me the tool or whatever that's gonna, suddenly make everybody love learning. And then you're like, I try to be as, how do you say, reluctant to bring in any new tools or sort of disruptive ways. If you work in the Microsoft universe, I will set something up in your Microsoft universe so people know the tools. They don't have to log into a new place. They don't have to, mess around with getting a new account somewhere, which they will forget in 2 weeks anyway. Just do it the path of least resistance when it comes to sort of bringing on something new. And eventually they will be like, oh, wow, I know these things now. So if you're setting up some sort of readiness program where you want people to start using these kind of tools, make sure to set that up then in the tools that you want them to use. So you make it not too hard.
Yeah.
Awesome. And time is flying away here a bit, and I'd love to also come to the paper that I haven't actually read, but I get very excited about when you speak about. So if we could.
Let's go there.
This is today's learning session then.
We I think we might be jumping over we've been talking about competing with the United States because it's a competition. But there's another.
But
big,
it shouldn't be. But
there's another big competitor out there as well, apparently, right?
China,
and they had released a pretty famous model now. But
we haven't said anything about DeepSeek. Do we need to go there a little bit first?
It's another new model that came out. So let's jump straight to the nerdy bits. I wanted to challenge you to show me a cool paper because I found a really cool paper, and I already know that you like this kind of stuff. Tom Goldstein is a guy that I know that runs a cool team in the US. I forget which university it is. I should probably be able to find it here. It's on archive. But the paper they released, and they released the source for their work, is titled Scaling Up Test Time Compute with Latent Reasoning, a Recurrent Depth Approach.
Okay, I get less interested now, but okay.
I know, you have your favorite approach to
the latent space stuff. He missed the word space and then he's seen.
No, it was the test time thing that I reacted to, but still. Okay,
Tom Goldstein has done a lot of stuff a long time ago with sort of visualizing the internals of neural networks using 3D and that kind of thing. So I always thought it was pretty cool.
Was that you showed me ages ago some really good videos? Like
I made my own Julia implementations that were much faster than the Python ones that they made, but they invented that sort of visualizing.
You did yours in Julia. The really beautiful one was made in Julia.
So what they did was they introduced.
What was the title again, please? If you could repeat.
Yes, the title is Scaling Up Test Time Compute. So inference time with latent reasoning. Okay. So rather than doing
the latent part I love. So
yes, and it's because there are a couple of they chose a specific architecture. They trained on 4,000 AMD GPUs for 12 hours for 21 days, and they built I'm pretty sure it was 3.6 billion parameter model. Pretty big, but not at all big compared to today's models. And the whole point is that they chose a non-mixture of experts approach because that was too complicated. There's many cool things here. They added recurrent layers in each layer so that instead of it doing chain of thought reasoning per token afterwards, it was allowed to determine how many recurrence operations to do inside each layer. Now, there are a couple of cool things that happened here. The first thing is when they slid it manually, they could do tests on whether it was their architecture that gave good performance or the recurrence that gave good performance. By limiting the recurrence to one pass, i.e. no recurrence, they got a certain score, and then by bringing it up, they got another score. So the score that they got with no recurrence was pretty competitive for a 3B 3.6b model. When they turned on recurrence, they could pretend it was more parameters, i.e., as if they had had that many more parameters depth-wise. So they can turn it up and say, I'm going to do, do 4 cycles, which would be the equivalent of an 8.3 billion parameter model otherwise, but it's still 3.6. It's just it runs many times through. And now the performance suddenly goes up. And it seems to sort of plateau out at around 30 to 50 B, hitting peaks at around 80 B. So it as a 3.6B model, it's competitive with 80B models. And then
how
it doesn't
many
seem
recycles then, you think?
32. Oh, that's a lot.
Yeah.
So they tested
32
48 and 64, and it didn't really improve. But they tested on Arc Challenge, OpenBook QA, and a couple of other benchmarks, and it's very cool. It really does get that much better. Now, there are other things that one might want to do, use mixture of experts and that kind of stuff. And what's really cool is, now you choose one or many experts and then run through them. But with this model, for every recurrence, you might want to choose a different expert. So the downside with experts is you still have to have them in memory. So it takes up space. And you only get an advantage because fewer parameters actually have to be calculated because you're only activating a few of the experts. But here, you could even have both advantages. You don't need as many parameters because you're doing it recurrent, and you can have lots of experts so you get really fast forward passes. Now, what else is cool? Well, the way they use sort of skip layers in here the novelty of why they got this to work was specifically that they use skip layers and other stuff to sort of get the model to train, because what's hard about these big models is just getting them to train at all. So the architecture is a little bit neat, but there were some sort of cool things here, like if you want to do some performance improvements, like having a shared key value file across layers. With a traditional transformer architecture, you have to train with that in place. You can't change it after the fact. But in this one, for some reason, it seemed like the recurrent layers were able to adapt to having a common key value.
Like a fixed one, or what do you mean?
Yeah. So they can share it. Mm-hmm. And so you can iterate over the recurrent layer and have one key value matrix, meaning you don't have to have all that extra computation. So again, increase in the forward, in performance in the forward pass. And then finally, because I said this was one of the coolest things, because this team was so good at visualization, I suspect, they sort of tracked the journey of the activation through latent space. And they found, because it's happening in the same recurrent layer all the time, they can track sort of where things are headed in latent space. And they found that certain types of questions resulted in, I don't know if you can bring it up there because it's a very nice visualization. Let's see here.
Try if you can cast it.
Here we go. Let's see. There was no title for it. But when you visualize using PCA, sort of the trajectory of a token through this recursive layer, the type of question generates different types of orbits or movements throughout latent space. So a mathematical question, and this is really a geometric representation of the compute graph inside latent space. So when it's thinking about math questions, it makes sort of elliptical orbits. And when it's thinking about other things like right and wrong, it'll have more, I don't know what you should call it, maybe polytope orbits or something like that. But it's so cool that you can see a geometric shape inside of latent space.
How it thinks.
Yeah, basically like a geometric shape that is the representation of the compute
This
graph
is
used
math
to solve
thinking.
a problem.
It has this shape and this.
Exactly. Solving logic has this shape, computation. That's a little bit cool.
So they call it test time, but I guess the recurrence happens in training time as well, right?
Yeah, of course.
So why do you think they call it test time?
Well, because you can choose how much recurrence to give it to sort of scale up the performance.
But it still happened in training time.
I'm not sure. I think they only trained with one. I'm not sure actually how they did. I probably should.
The reason is I'm very annoyed with the term test time compute, so that's why I'm getting a bit interested here. Did they
What's
actually
the
do
annoying
that?
part of it?
Because if you take O1 and R1 and whatever model, if you think they're only doing test time compute, you're wrong. I mean, they are doing the reasoning and the multi-step reasoning during training time as well. And people still keep calling it test time. And it's not just during testing, it's actually during training as well. They should simply call it multi-step reasoning or something. It's not only in test time.
Architecture.
But for this one, I'm not sure. I think they are doing recurrence during training time as well.
I would be surprised if they didn't. The thing is, I wouldn't keep it against them, because I know Tom Goldstein has made other papers where he has trained optimizers to do one step and then do multiple steps after that. And so I know it's difficult to do it on one step and then just do test time multi-step predictions. So I think that's probably what they would want. But given that it's so difficult, it wouldn't surprise me if they trained with multi-step for convergence and for everything else. But it is cool that you can have such a small model and that you can get it to be big just by giving compute. And I guess I just want to do a small shout out here. I know a lot of this is tying it into hardware nerd stuff, but a lot of laptops that have gotten attention now are the MacBooks, because you can load big models on them, and they have super high memory bandwidth, which is nice when you're generating tokens per second. But for computing stuff and for pre-processing stuff and for evaluation and all that, that's all compute bound. And this is all compute bound as well. So, the GPU in a MacBook is pretty sissy, and you still want a powerful GPU. And hopefully that means that future models
But you don't want a MacBook, by the way.
No, you don't. Nobody wants a MacBook in their right mind. Yeah, so anyway, I just thought it's cool that this is very compute heavy rather than memory bandwidth heavy.
But coming here then, sort of representing the village idiot when it comes to these things, how would this tie into the common thing that we had earlier? How do we? Is this something that can be utilized if we want to make sure that we're not losing in this game of making sure to bring value from these kind of things?
Can I just make a little attempt at explaining exactly what this sort of entails, I think? So we've learned that if we make really big models, they do better. And what this one is trying to do is the following. One of the reasons big models do better is the wider they are, the more things they can remember, and the deeper they are, the more steps they can use to think through things. And what this one is doing is, instead of having many steps built into the actual model file, it's making the file smaller and then sort of calling the same layer many times. So it's pretending to be deeper than what it is by recalling the middle layer many times. And then there are other techniques, mixture of experts, which instead of calling all of the width, only calls part of the width. And all of this is to get the advantages of the big model and run it with as few resources as we can. So
when you say expert and then you say certain things, is it does it know which part that it needs to call?
It does. I guess one thing that's
expert?
worth clarifying is that, let's say you have a model that has 10 experts. It's not like one is an expert on medicine and one's an expert on biology. It's more like this one knows a bit more about this question, so we'll let it answer.
Let me try to also explain it for the purpose of...
This is so fun to try to distill it.
But, we are saying that some kind of reasoning, even though it's a shallow type of reasoning, some kind of reasoning is happening in these big transformer models, including ChatGPT, etc. And people have said, if you increase the number of layers in a model, the amount of reasoning, the number of steps you can think increase in some way. Also, the context length, the more tokens you can look at in a single window, the more reasoning you can do. So the reasoning powers, in some sense, is bounded by how many layers, which increased number of parameters, and the window length, which also increases the number of parameters, making these models that do reason well super big. What this one is potentially doing is saying we can have many layers without having more parameters in some sense. So they are going through the same layer many times without adding more parameters, meaning you can have more reasoning without adding new parameters to it. And that's really cool, potentially. And that's why, you know, potentially they are having recurrence in some kind of middle layer, which is a latent space where they do more reasoning then. It's not the type of latent reasoning that I would hope to be, but it's a small, simple one.
It's a kind. And it's worth comparing to what Grok does today. So basically, Grok does this, even though it doesn't have this middle layer that spins. Instead of spinning in the middle like this, it actually spits the text out and then sends it back to the beginning and then reads it again, which is very inefficient.
Yeah, so and what we can look at here is then basically, when we're talking about innovation, there's so much research and innovation going on, not only around making it more intelligent, but making it way more efficient. And this is cost efficiency, compute efficiency, bandwidth efficiency.
Which of course makes it more usable.
Which is ultimately the whole discussion on total cost of ownership. Yeah. I saw a number, you know, if you have a standard question and you wanted a certain, you know, with a certain token with a certain quality of answer, there was some number in the beginning that was like a $60 question. You know, the amount of compute that goes into this question equates to $60. So if you now compare if you do the same type of question in the latest models, we are talking about the cost per question going down to 60 cents. So so this is what we're talking about, right? And this is part of making this. You know, so we're talking about, you know, this is going to go crazy, but layering, you know, when we are compressing and doing all that, it means we can fit it in the phone, you can fit it on a normal computer, and you know, it's part of making this useful. Is the cost in the end, ultimately.
But I also think this is super interesting because it's. I mean, we love numbers. We love big numbers. We love the people who. Just throws everything in there and does huge things. And just like you were talking about, you know, what you have in your sort of field of sight. Is that the correct one? Yeah. But there's so much stuff happening on the sidelines where people are just trying to make things smarter or more efficient or make it work better or those kind of things. But it's not as sexy because it's, you know, it's not the world champions.
And tying it back to what should Europe be doing? You know, should we really be there to build the biggest models, or should we be there to build the most smartest, most efficient, useful model for normal application? And because there's one thing to crack AGI, but we can have the 90% of the immense value of the work we do today as people. We don't really need AGI to automate that. We just need it to work efficiently, cost efficiently, especially. So I think, you know, the more you think about this, what is our competitive edge? You know, where should we go with this? Then you can go and do amazing engineering and do something that's very, very useful and very, very much cutting edge and has nothing to do with building the biggest Colossus cluster. It's the opposite.
Yeah.
Okay. Anything more about the cool paper, by the way? That
yes, I just wanted to answer your question. It says here, to enable synchronization, we sample a single depth R for each micro batch of training. So it sounds like R is variable. So you were right. But I wanted to say one last just super cool thing. Because you could potentially do one forward pass and sample the output before you keep going, you get like a fake kind of speculative decoding from this. That's sort of cool that you just get that for free.
Yeah, I agreed. I still want to go to the JPEG paper because that, I think that's really the end
best
goal.
one.
I mean, that's still, I think, the best way to go in the end.
Because you sort of latent space has been a topic that we've been circling back to. Maybe we should do it a little bit here. Like you've been talking with us about this before. It is latent
space even.
Yeah.
Okay, so we're moving more to the futuristic kind of, you know, what could the future of AGI be, and speaking about different paths towards that, and just contact into this paper then, and speaking to JPEG potentially, but we are. Let's do it like this. If we take image generators of today, like DALL-E and Stability AI and Flux and everything, they actually do reasoning in latent space. And if I
currently,
yes,
with noise and stuff, but
but they basically have an autoencoder around the pixel. So if you take pixel space, if you were to do reasoning in pixel space, it would be super high dimensional and very low level of abstraction, and it would be super inefficient. So what all of them do is basically to first compress the pixel space into some kind of latent space, and then they do the diffusion to generate the image in that kind of latent space. So they already moved in this direction that I'm really excited about, and I hope that we will come to, and which is what JPEG is speaking about, having these kind of joint embedding into a latent space and then doing the reasoning there. So we already see reasoning, like for image generators, happening in latent space. We're not seeing it for text though yet, which I think is a bit surprising.
Why is that?
So text actually is in some way actually rather high level of abstraction. It's far less high dimensional than pixels are, and they are actually rather high level or semantical in that sense. So in that sense, it's not so horrible to have to encode and decode to every token through every forward pass or every autoregressive pass that you take, even though it's super idiotic.
It makes more sense in character-based languages than in English, for example. Like Chinese, where one character can mean an entire word.
Yeah, but still, I can follow Jan LeCun's point of autoregressive models is stupid. Because if you want to have this kind of reasoning, why should you need to decode to a human understandable language every time and instead do the reasoning every step in the latent space, which is actually what image models are already doing? Why couldn't you put an autoencoder around a piece of text and then do the generation happening in that space? I think this is actually where we potentially will be going at some point. This is just me speculating. And then you can think also if you can join this kind of latent space for different modalities, meaning text and images and audio potentially, and say they actually understand each other in this latent space, which is like think clip, if you know that kind of model, that would be amazing. This would be a possibility for us to do a reasoning in a super efficient way, because we're working in this compressed latent space now. And then we can avoid having to encode, decode all the time. We can understand across modalities, and it would be so much more efficient. I think it's for me obvious that this is a direction we need to go.
Have we seen any paper? I mean, like JPEG paper it's already 1 year old now or more.
Yeah, but that's a position paper.
That's a position paper. Have we seen any real work?
So we have and we have VJPA, so they're starting to do a bit of it. We see all these kind of image model already going in that direction. Not so much for text though yet, which is kind of interesting. What do you think, Robert?
I'm not sure. I think there's so much momentum behind the existing models, and that there's sort of clear paths to improving them as is, that nobody dares to start from scratch with it.
Yeah.
And that is what, this kind of work is a little bit. But I think there's two avenues to research in this field. One is probably trying to model things after the way we think humans do things. And there's good reason to do so, because we believe that the optimizer of natural selection has done a very good job at making our brains, at the very least, energy efficient. So it's a good way to sort of process data cheaply. But there is probably another avenue of research, which is what is the best and coolest way to do it. And so I don't think they're mutually exclusive necessarily. But I think one of the cool things that Clip showed us, and even before Clip, was that early language models improved the more between two languages. Yes. When you taught them other languages that you weren't actually translating.
Learn across languages.
Exactly. And then with Clip, it's the same thing, that understanding images made them better at language, presumably, and this is where we speculate, and I just think some people are better at speculating than others. That's just the way it is. But presumably there's some kind of semantic representation. That's why I really liked Jan LeCun's representation learning, like the coining of that word, that there's some kind of semantic representation of something in our minds that is allowed to occupy the space that gets activated for both the word beer, the sound of beer, the taste of beer, and everything else. And there is a lot of scientific evidence to back that kind of stuff too. It's a shame that the fields aren't really converging on stuff, and that people like Hinton are getting so much flack for trying to sort of speak across fields. Have you guys heard of the what was the woman that played Storm in the X-Men called?
Is this Halle Berry? Or
Halle Berry, yeah. There's a paper called...
Wow, that is a reference.
There's a paper called The Halle Berry Neuron. And it was a guy that had electrodes connected to his brain where they were trying to figure out what parts of his brain were activated for certain kinds of stimulus. And they found out in the end that he had one single neuron that they could find that always activated when he heard her voice, when he saw her picture, when he heard movies about her and everything else. And they ended up calling it the Halle Berry neuron. And presumably that is sort of the one neuron that activates maximally when every other neuron sort of the hearing part of his brain and other parts of his brain. And I just feel like it's so analogous to the way we do things. And these multimodal models in latent space, of course they should have a single representation for multiple modes of input. So it feels intuitive to me, at least, that would be the energy efficient and good way to do it.
But and maybe this is also like, because we are talking about something that now becomes very abstract because we have our different senses. So it's really hard to think about it. Can the brain have another lingo that ties them all together, and why not? But it becomes fairly abstract.
But here's what we can't do as humans. Oh my God, this is super. Now we're going sci-fi. Remember those papers that said that when robots were able to talk to each other, I think it was Meta, they came up with a language of their own that was more efficient.
Yes.
That seems natural. Okay, well, we can't speak to each other in latent space. That's why we use words, and it's a very what do you say?
Crude?
No, it's very high compressed, serialized.
High-level abstraction, right?
Yeah. Serialized unidimensional format of transferring. And I remember there are these sci-fi books where aliens can talk to each other by sort of exchanging DNA via osmosis and sort of talking really fast that way. In any case, AI systems could potentially speak in latent space with each other, and we wouldn't understand what they're talking to each other about. And
that's what Neuralink is about, right?
Yes.
So the reason behind...
That is exactly it.
Exactly, right? So the reason behind Neuralink is that the communication bandwidth between humans is horribly slow. Like bits per second.
Yeah, sorry, that was my sort of jump into what you were saying with being crude, because of course our use of language is very crude. That's why we, why we put so much effort into people who are good.
Very low bandwidth.
Yeah, and people who are good at communicating.
So if I had a Neuralink chip in my head and another in Henrik's, we can actually communicate in gigahertz
bandwidth instead.
Maybe. Would it require that you two had the same weights?
No.
That's a good question. We have to have synchronized latent space.
Synchronized latent space, yeah.
Which is a good point. It's probably very hard to do.
But it is my dream to be like in Ghost in the Shell and speak telepathically.
Ghost in the Shell.
We should be able to do with Neuralink.
Yeah. Awesome. Before we end, I'd like to speak a bit more about Julia, perhaps, and just the future of programming and the role of a software developer, etc. So we spoke a bit in the beginning about what will happen as we are getting more and more domain experts that may not be technical experts, but still using chatbots efficiently because you can simply prompt them in different ways. And if you can prompt it properly, you can actually build stuff and do stuff. What do you both think? If we start actually, because I know a bit what you were going to say, but I want to hear Louise first, perhaps. What do you think a software engineer or someone that builds an AI system, it may not be, it would be wrong to call it a software engineer, but what do you think the future will be when we build AI systems in 5 years? How do you think that will look like?
Interesting. What will it look like? I think that there's still going to be, the people who say that you don't have to have any sort of field knowledge, if we then talk about building stuff, engineering, I have a hard time thinking that or seeing that that's going to be obsolete in the near future. Both tying back to the example that you gave about the woman at SVT, the old journalist, who was so much better at sort of using the tools. And there's something I don't have perfectly formulated, but I think
is she using the tool, or is she actually building applications by prompting it?
Exactly, and that's probably the question then, the follow-up question about what do we mean when we say building stuff? Because as soon as we start going into this whole agentic thing, which obviously is not my area of expertise, but what you are doing is giving people sort of the possibility of building things by being able to give instructions, which of course can tie into, how do we build? How does Elon Musk build this, Colossus? Yeah, he's really good at understanding what's needed and giving instructions to people. or to something else. So, and we see him as somebody who builds stuff. So of course, if you bring that sort of into what building means on a smaller scale, that is the same thing.
Let me go next before we get even nerdier like this. I think when we are talking about engineering, I think on the one hand side, we will get to more and more better self-services platforms that allows everybody without the back-end coding skill or really infrastructure skills. That cognitive problem is gone, and now they can focus on building whatever problem they need to solve. So here we now get one type of engineering which is very close to what we do, and which is then basically based on very efficient self-service architectures. So this is engineering in the one hand sense that actually we might have many more engineering people. So we are democratizing engineering close to the workflow. However, to do that, the intricacies of building that self-service platform and to run that platform and to operationalize that and to have the quality controls and the data and etc. to build the agentic AI platform and to build the agentic AI monitoring and governance, to build the agentic or the data underneath the data mesh serving the agentic plane. This is a shitload of engineering that goes into building these self-service products. So I think there are two distinctions of engineering that we need to think about in the future. And then the third final topic. So even when you are now going into the platform, the really sophisticated stuff, the engineering field, the toolbox that these engineers will use will abstract away how we code. Also, we will work on a different level, but you need to be a very, very, building robust systems. You need to be very knowledgeable of what makes a system robust. But the way you get there is not in assembly, and it's not in C, and it's not in Java. It is in something else. It's in different types of editors. So that was my take. So 3 angles to that question.
Yeah, I just want to add on that I don't think the role of the sort of the expert, the person who knows all the ins and outs of stuff, that's not going to disappear. It's just going to sort of change.
If you build a platform, even if you're telling someone to do stuff for you, you're instructing it, you kind of need to know the ins and outs and the blind spots of building robust systems.
In order for you to give good instructions, you need to know what it is that you're asking for.
Exactly.
And that's not going to sort of suddenly disappear. And I think that's super interesting, and probably not for this conversation, but how do we see the future of grunt work? Yep. How do you actually get to the point when you have good intuition? How do you get to
should we teach?
Exactly. How do you get to a point where you are the most able to use all the different tools that we're given? And I don't think that's super clear, and I don't think definitely not it's clear, out in the industries and in the fields.
There is a thought experiment here. If I will never any more work in the process, I will always work on the process, because I will then set up an agentic flow in the process. Then we all are engineers on some level for our data work, for our workflows. We are engineering our workflows up here. So engineering thinking or system thinking becomes super important to be a guy that can work on the process rather than in the process. So then we're all engineers. That's an interesting thought, right?
We're all AI experts.
Henrik,
but it's like, we don't need an engineers. And I use flipped script.
That's why I needed to coin this AI wizard term, so that there's another tier of it. I think there's probably 2 kinds of AI developers in the future. One that uses a lot of pre-made stuff. And I know, if you base things on Azure and Microsoft stuff, Microsoft will say, this is how agent stuff works. Deal with it. And you're like, yeah, I'm cool with that. Well, then everything's great, because then you just press next, and you can just build these incredible things. But as soon as you want to, first of all, transfer your knowledge from Microsoft to something else, but also, just edit it a little bit, you basically need to know everything. And I'm sort of catching myself noticing how unreasonable it is to have to know all this stuff. You have to know infrastructure stuff. I mean, just consider this. As part of the stuff I'm doing at SVT, we're using Redis, a NoSQL database, as a state machine. Not everybody has studied state machines and know about race conditions and stuff like that. There's just so much you have to know, more than what you had to know as a data scientist before. And it's just fewer and fewer, far between people that will be able to know this stuff. So I don't think it's going to get easier in the future. It's only like really enthusiast people that are going to be able to keep up. I feel like I can barely keep up with this stuff. But to sort of address the question of programming in specific, I was just a little excited the other day. Julia released a library called GPU-kernels.jl, which is a way of writing GPU kernels that is runtime agnostic. So if you want to run on Metal, you want to run on Intel's platform or CUDA or ROCm, you can just write once, run anywhere. Trademark.
Will you code Julia in 5 years?
I don't even code Julia today, which annoys me a lot.
Okay.
But no, I'm actually going to try and code some Julia stuff. The don't ask for permission approach.
You had to regress to Python.
Yes, unfortunately, it's impossible to rebuild all the AI stuff from scratch in Julia. It's just takes too
The
long.
libraries is there. Come on.
Yeah. Well, nothing is written in Python. Everything's scripted in Python. Don't get me started.
Don't get me started. There's nothing written in Python. It's scripted.
No, actually, the guys at SVT are experts in TypeScript.
Ooh.
So they are super good at TypeScript.
Why? How did that
TypeScript
come?
compared to Python is even a good language. It's strongly typed. It has lots of support from tools that are really, made for making big enterprise software.
How did they get into TypeScript? What was the angle there? Why they?
They started with front end stuff and then Node and then TypeScript because JavaScript is, not for building serious applications is not good enough. And so it became TypeScript. And surprisingly, TypeScript is pretty good.
Yeah, cool stuff.
What are you coding right now, Anders?
It's
Python?
Julia.
Not Julia.
It's not in English, probably. No, it's still Python, of course. But also a lot of other language. I love TypeScript as well. I think it's actually very beautiful. But you know who coded in something else? If you take DeepSeek, do you know what they coded in to build their models? Have you heard?
No, I haven't heard that one.
PTX. Have you heard about it?
Isn't that the stuff straight for... no, it's not for Google's processors. They didn't use that.
No.
Did they use MTT stuff or did they use... they used NVIDIA, right? Old NVIDIA cards.
H800.
So what is it?
So what is PTX?
So they have different levels, like PyTorch is a certain Python level. You can go to CUDA level, which is basically C level language. Then if you go to assembly language, underneath CUDA, it's actually PTX.
Yeah, I heard. Now I get it.
Which then compiles to the machine-related language underneath. So they went super low. In the other direction here, actually.
But that's because they had to rewrite the NCCL libraries and stuff like that to do
this
it.
is exactly right. Have you heard the Lex Friedman 5-hour marathon on the AI? You need to. They have a couple of cool guys, and they're picking this apart, and they were explaining the whole. They're talking about geopolitics down to coding. So very impressive guys, and they were explaining this exact point that because they had these limitations. They, and what they wanted to do with mixture of experts, the CUDA library couldn't keep up.
Yeah.
So they need to fucking do it from scratch.
But how many experts they had is like over 1,000, right?
Yeah, so anyone that says that DeepSeek, it's just a cool kid, so 5 people that were on the side time and did some stuff, that's horribly wrong.
This is hardcore
super
stuff.
experts.
I think that's a great description. I think people underestimate. I mean, when I mean cool kids, like you're not cool if you're that stuff is cool. That's super cool. I mean, these are cool hackers.
No, but this is not bullshit stuff. This is hardcore engineering stuff.
Yeah, this is hardcore stuff.
Yes.
Yeah, really hardcore stuff.
So these are really advanced people with a lot of skills.
Yeah, and when someone
frame it as something else.
And it's
Why would people frame it as something else?
because it wasn't research, it was stolen, it was blah blah blah. Anyone could have done this.
This is interesting because I mean,
They were downplaying the
They wanted
engineering
to make
feat.
it sound like it was super simple to do, and all the value that NVIDIA had was useless in some sense, right? So all the time that OpenAI is spending on this is not really worth it, and it's super simple for 5 kids that have no skills can do a lot of stuff. But that's not the story. It's so wrong.
And the story was literally, I mean, like everything you plummeted, when in reality there's been some amazing engineering done on
But this is an
PTX
ultra
level.
ninja team.
This is ninja team. This is
it
proper
is.
ninja team.
Okay, anyway, I think, one other good anecdote, or metaphor rather, to have about the future of software engineering, which is also from Sam Altman. And he said, they actually made a bet, I think, to Elon or something. No, not Elon, someone else. They're not friends. Anyway, they made a bet saying there will be a point in a couple of years where we'll have the first one-person unicorn company. A company that is worth $1 billion, $1 billion. And it's going to be started and operated by a single person. Actually, Instagram was not that far off. It was basically 13 people when they sold it for $1 billion to Meta.
That's quite many years ago.
It is. But we still haven't seen a single company being worth $1 billion. But that's potentially is going to happen. And if you think that's true, it means that humans, as a single person, needs to be able to handle a huge variety of tasks, becoming increasingly general. And what
Not generally bad, generally good.
Yes.
I think some people mistake that. So
Yes.
we need to be increasingly good at very many things.
Yeah, but you don't need to do anything. You can ask your ChatGPT for your market strategy. You can do this and you can do that. So I think it's the thought experiment you get into then. What would be the university degree, or what would you study, or what is the competencies to build the first? What if I'm going to be the first one-man unicorn, what is my skills trait? What is my profile to succeed with that? What do I need to have? I need to have some things. I need to have vision, creativity. I need to have from 0 to 1 thinking, Peter Thiel. I need to have system thinking as well, because I need to figure this shit out, even if I'm prompting it or blah blah blah. But it's an interesting thought experiment. What would that be in terms of competences?
It is.
I want to say one last thing about the democratization of skills that were only available to skilled people in the past, which programming is. You have to be an expert to be a programmer. And now anybody can prompt and get quote unquote crappy code according to the expert programmer. That's exactly what has happened with recording at home studios. People are like, oh, it's better to record at Ocean Way Studio. Yeah. It costs millions of dollars, and now this person can get 95% of the way there at his home studio, or maybe just as good. Anything that democratizes exclusive technical or physical skills or anything like that, I think always lifts the boats for everybody.
Yeah.
And just as a fun anecdote, this morning I listened to the Donkey Kong soundtrack, which was translated to sound like flamenco guitars by a sort of translation service, and it sounds perfect. My guitarist said it sounded like a real person playing guitars, and that is awesome that an amateur can make something like that.
As a musician, are you happy with all the music generation services coming out now? Or
all the musicians that I speak to that do it for the love of writing, meaning they're poor, think this is awesome. It's just more cool stuff to make art with. So we're all pretty excited about it. I think the record labels are probably mad.
Yeah, I'm sure.
What was your take on the software engineering based on the one-man unicorn thought process?
I mean, you can think about the skills. I think that's a super interesting question. What should you tell your kids to actually, learn and teach in school? And should I quote Elon? People get so angry when you mention the name Elon these days, but I think he has a good point there. His thoughts is basically physics and computer science. And you can think, why is that? Well, physics, I think, is rather easy to understand. You need to understand how the world works in some sense. I think that's a super useful thing to learn, and rather complicated. Computer science, well, you know the world is digital. You need to understand how that works. Even though you may not be an expert programmer, you need to understand the basics of how computers work to be able to tell it how to build stuff. So I think that's actually a good point. If you compare it to other things, like, okay, do I need to know how economics works? Do I need to know how marketing works?
Not really.
Do I need to know how to build a factory? Are physics okay? I think, potentially going closer to the STEM fields, mathematics and physics and engineering in terms of computer science is probably, I think, is a good idea.
So if you start with those two, and then we have already spoken about the third one, communication skills.
Good point.
So I think you can never, if you want to build a $1 billion company, you damn sure need to be able to sell and communicate your ideas. So communication,
interpersonal skills,
interpersonal communication skills, building relationships together, and the other angle. I'm reading Adam Grant. Have you heard? There's a book called Think Again, who's basically exploring the challenge of unlearning to relearn, so to speak, and he's arguing around how we can get more methodic doubt into our ways of thinking in order to see our flaws and fix stuff. So he argues then also, another angle why the STEM fields is that there is a difference between our mental models. Are you thinking like a scientist, putting up an hypothesis, having methodic doubt, and then trying to reject it? Or are you thinking like a politician, trying to convince people? Are you thinking like a prosecutor, always trying to make your thing the right way? And he's sort of having an understanding that whether we like it or not, we fall into these mental models that we in the arguments. And the most useful thing when we really want to understand our blind spots, our flaws, and even to the point like if you're a startup, they were doing a survey, this is psychology, and people were training in scientific thinking and then ending up pivoting on their idea, and how many that came to success versus the one that sort of they were stuck in their idea and they were prosecuting everybody, or they were a politician for their first idea that was actually wrong. They didn't have market fit. So this STEM thinking also goes into fundamental scientific thinking, and we are not all trained in that.
No, definitely not. I mean, it's the difference between, when we're talking about communication or something in whatever, but the difference between arguing, which is sort of making the other person admit or something, or just leaving them.
Persuade.
Yeah, exactly. And having a discussion where you actually end up understanding what is the problem we're having, what is our view on it, do I understand you, do you understand me, and then you can actually get to a point where you get to a proper solution of something. And of course that is the scientific way.
This is the scientific way, actually, to have methodic doubt that I might be wrong, instead of me prosecuting you because you're not thinking like me.
It's
anyway,
like Trump, right?
So we have the Elon approaches, STEM. We add communication and interpersonal.
Yeah, I like it.
I kind of like it.
Cool. Should we go with the last obligatory kind of question as well, perhaps?
Well, I don't think it fits today.
Okay.
I think we need to have another question. We need to think it up on the spot. No. I'm putting myself on the spot. We all, so.
What's the usual?
So.
We haven't heard Louise's points of this.
Okay, good point.
Are you going to put me on the spot now?
Let's put Louise on the spot. Let's put Louise on the spot. While you do that, I'm thinking about a final question that will blow your mind.
Okay.
Louise can take off question.
So, Louise and Robert, assuming that there will be a point, perhaps a number of years in the future, where we will have AGI, where we'll have systems that is at the level of an average coworker, not only for perception, but also reasoning and agentic kind of taking action abilities. What would that mean? You can think about two extremes. One extreme is basically we end up in a utopia, what Nick Bostrom wrote about in his book Deep Utopia, meaning we've cured cancer, we've fixed the climate crisis, we have fusion energy, and we have basically a world of abundance where goods and services are available for free, like Star Trek or something.
I like Star Trek.
Yes. Then we can have the other one, which is a dystopian world where we have the Matrix of the world and we have the Terminators where machines are being built to kill us all, and we're living in a horrible society. Where do you think we will end up? Will it be more towards the utopian, more towards the dystopian? What do you think? Super easy question.
Yeah, no, I'm definitely gonna go for the utopian one. I'm a positive spirit. No, but I think I don't know how to reason to it. Maybe because it's so boring to think.
Are you afraid that an AI system will exist that is superior in more or less any way than yourself in the future?
My spontaneous response would be no, not afraid. And that is because I would say it would be a hard time to sort of judge what that would look like, because I don't think there's such a sort of binary divide between what is or what isn't. So that makes me fairly confident to say that no, I'm not worried. And I do think, it would be so boring to think that all the good stuff that's happening would somehow, lead us towards complete destruction. And as a historian, I could probably say that, when we've faced big shifts, and it's hard to wager, which has been the bigger shift over history of time. But people have always painted the picture of like, this is bad. And of course, because
they always predict dystopian kind of future,
because we disrupt systems and ways and rules of how things have been established and worked. And that is, of course, really, really frightening for the people who are on top today. So, I mean, of course, people are going to be very negative about it, or paint the picture of like, this is, hell knocking on our back door. And I don't buy that.
Awesome. Robert, do you have any?
Are you capping the intelligence at human level intelligence?
No, it's ASI. Like
yeah. There's no reason that I see that we would be like the pinnacle of intelligence.
No, absolutely not.
And so
I'm so limited myself. So.
I feel pretty confident in saying that I am superior in every way to a 5-year-old.
Annoyingly.
To a 5-year-old.
Yeah, to any 5-year-old, I would just beat them at everything. Everything you can imagine, except maybe humor or being silly or something.
Asking questions, probably.
Asking questions. I don't know, man.
Yeah, I think so.
So, sort of by that way, I can envision an AI that is similarly superior to us in every single way. And that doesn't necessarily mean it has to be the Matrix dystopia, but I don't see how we are the ones in control of anything after that happens. No. We wouldn't let kids run our government today. Why would the AI
But
let
it
us
doesn't
do that?
necessarily have to mean that we go into dystopia.
So if you go that route, where do you end up? Let's say that the AI will consider you a 5-year-old.
I've left breadcrumbs on the internet, so hopefully they remember me as one of the good guys. I don't know. Maybe they keep us in a zoo or something.
Yeah. But I just want to add on to
It's
that.
fairly dystopian.
The zoo. Well,
Not necessarily.
I think dogs have it very good.
Yes, exactly. Right?
No, but I think my response to your question about if I was worried is that I don't see ourselves as the pinnacle of the height, but I'm not worried about it.
Yeah.
No, but then children shouldn't be worried about their parents
exactly.
helping them out either.
Exactly. Right.
I mean, I would be so proud if an AI that I was part of making would be good enough to be able to help us to do better things. Why wouldn't one want that?
Yeah. Agreed. Henrik, have you thought about some other?
I have a question. Let's see if I can. It needs to be this whole setup.
Cool.
It's a whole setup. Okay, so we started with the setup. Way back, Recursive wrote about the law of accelerating returns, and maybe we can today understand it as an accelerating productivity frontier. Sam Altman said, somewhere, I think it was in 2024, you need to think about the trajectory, not where we are. And then he did the example that if ChatGPT 3.5 was good had quality for 5-second tasks, then 4.0 was good for 5-minute tasks. Then the next one in line, if it's ChatGPT 5 now, is good for 5-hour tasks. And then you multiply that, you get to a month, right? So if the core question then becomes, how should companies think here and now to better organize for a trajectory and not where we are? So what would be our advice, or what would be your sort of number one? Okay, if you really want to think about this, not where we are now, but to be ready and to be surfing the wave and not surfing the AI tsunami and not drowning in it. What is the key ideas on how to organize for the trajectory? Where would you go with that answer if someone asks you?
I think a lot of companies should be asking themselves if they have the guts to make the changes necessary, and who are the people in the company that will sort of spearhead that charge. Do we have people in the company that know the right stuff to make that kind of a charge? I've always felt that AI is always, for the past few years, that AI is very much about entrepreneurship. You know, you have to like dare to reinvent the company. And I don't know if everybody has the entrepreneurial spirit or willpower or mindset or any of that kind of stuff. So I feel like it's linked to that very much. And I know I'm sort of leaving out where things are headed or what you can do about it, but it's more like if you're dropped...
fundamental.
Yeah,
are we ready? I mean, are we preparing to go here?
Look, if you're dropped into the jungle, you can't say, oh, I'm going to prepare by doing this and this. No, you have your knife, you have your matches, you have your compass, and then you can only prepare so much, but you can't prepare for exactly what's going to happen. You can only prepare by
being ready.
But I mean, that then, if I may, ties into my question, which is practically what you just said, but phrased differently. Know your problems, or know your business. I mean, if the equivalent of knowing your business is you're being dropped on an island, and you know that I need to fix water, I need to make sure that I, have some place safe to sleep. That is knowing your business. Without knowing that parts, there's no way for you to even start navigating about what you should aim your efforts for.
So you need to be clear on your goal, know your goal, know your value, know what you're trying to do. I think this is one part of the story. But I go back to this fundamentally understanding that this is, if you're not ready or prepared to take on the trajectory, if you are not prepared to walk out of the jungle, because you're stuck in the fucking jungle, if you're not going to walk out, are you going to live in the jungle or are you going to die in the jungle? So if you're not mentally prepared that I'm going to try to walk out, it will never fly. So this is something else, right? This is knowing your business. I know a lot of people who knows their business, but they're simply not prepared to start walking. I think what you're saying is quite interesting about courage here.
One last thing. One of the things is that preparing for being dropped in the jungle takes a while. You got to build up some muscle. You got to do some stuff. A lot of people think we'll handle the AI stuff when it happens. It's going to be too late.
Yeah, you need to learn now. You need to build your muscle memory now to be dropped in the jungle. Okay, good. Thank you.
We should take this jungle analogy really far in the next few episodes.
Cool. Thank you. Good answer.
Thank you. It's good.
Awesome. Yeah, time. Oh, it's 2.5 hours. It's too far. Okay, awesome.
We didn't even talk for so long about DeepSeek and stuff.
No, we even skipped topics, Anders. This is nothing, man.
Yeah, that's good. Well, let's stop it there, and I hope you can stay on for some after work discussion as well off camera. I'd love to continue to discuss about quantum computers as well. It's one of my favorite topics. We don't go there. Microsoft released a new Majorana chip, and
it was so superlative in all of the press releases and everything.
I have so many thoughts about
Are you opening up another topic now? Or what?
No. But it's going to be off camera, so sorry to everyone else. But
sorry to everyone else. Now the real cool stuff happens.
Yes. Anyway, thank you so much, Louise Vanerell and Robert Luciani. It's been amazing to discuss this, and I'm looking forward to the coming discussion as well.
Thanks, guys.
Thank you.